Welcome to APEC Open Mic. This is our introductory session. I'm Tim Ventura. I'll be moderating. I want to invite everyone to speak about what's most important to them in our community. We're talking about UAP reverse engineering, gravity modification, inertial propulsion, reactionless drives, warp drives, emerging space technologies, all of those things, right? And so the open mic takes it back to where things first started. We started this conference as an open discussion forum without a planned agenda, and it's evolved over time, but we wanted to bring that back and let people talk about what they're working on and what interests them and what's most important to them. And so this is kind of a free-form discussion. It is moderated, and what I want to do is read you basically how to get involved here. Again, let me start by saying that you can view conference replays, details, and speaker info for everything on our website at altpropulsion.com. If you want to speak in open mic, it helps to raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. So if you raise your hand, what I will do is kind of wait for an opening and then call on you. And that makes it just easy to know who wants to speak. Also, in our discussion sessions, people tend to jump in. I guess I would just ask that everybody be respectful, try not to talk over each other. I guess one of the other parts too is try to keep things focused, right? We try to avoid politics. We try to avoid things that are going to get people inflamed and upset, so to speak. We try and keep things focused on emerging propulsion and, again, UAP and UAP reverse engineering and the things that really are these focus topics for our conference. There is so much going on right now. I think this is an amazing time for open mic because there are news headlines happening for these things on a daily basis. So on that note, that's not an official introduction, but let me welcome everybody here. And again, I'm Tim Ventura. I'm just moderating. This is your event. So anybody who wants to start things off, and if you guys don't have any topics to start with, I can start. I definitely have some stuff that I've been following. Does anybody want to get going or? Okay. And Dawn's asking about time technology. Dawn, do you want to unmute yourself?
Yeah, let me unmute myself. Let me show myself too. Give me a second. My name's Don Tadaya. I'm here representing for the first time, and this is also APEC's first open mic session. So yeah, I'd like to introduce myself to the group. I've been connected to a lot of you already in the APEC WhatsApp platform. So some of you are familiar with me, but if you're not, I am the founder, president, and CEO of my passion project company called Gassian, and it also has a sort of capital partner that's called Gassian Capital, which is more of like a multi-family intergenerational. Which is more of like a multi-family office private equity management firm. But Gassian, sorry, excuse my dogs, but Gassian Capital on the other hand, we do our analytics, machine learning, geometric deep neural networks. So I've been working with people like the Scientific Coalition for UAP Studies, as well as APEC groups, and even Mark Sokol from Falcon Space. Just basically looking at the data that they have and being able to visualize them and autonomously gather and extract sort of valuable insights from their data sets. So if there's data sets that you have and you don't know what to do with them, send them my way, and that's what Gassian stands for. I wanted to come in here, introduce myself to open mic, introduce myself to all of you guys, and introduce my passion projects, Gassian Capital. So thank you so much, Tim, for having me. I'm honored to be here, and I'm honored to be with all of you guys.
Oh yeah, absolutely. Well, and again, the way our format is structured, and I'm sure once folks warm up, and there's Mark, so Mark will probably jump in too. You know, it's whatever topics are open to you guys. I think one of the things that I have been blown away about is what's going on with UAP, right? And I I'm at a loss for words, to be honest. I mean, again, just a few years back, I didn't believe in UFOs. I thought that it was all psychological, right?
Same here. Honestly, can I be honest about that? Absolutely the same way.
Yeah.
Absolutely the same way. Even after 2017, when Chris Mellon came out and and stood up to the Pentagon and almost sacrificed his social reputation as well as his reputation as former deputy assistant to the Secretary of Defense. So like that didn't really get me until I saw his article that he wrote with Tim Gallaudet, basically saying, hey, the ocean scientific community must put stigma aside and take this anomalous phenomena seriously.
Yeah. No, I'm 100% with you on that. I mean, it's been, and Don, the thing, and again, I would welcome anybody else to jump in here if they have thoughts or comments or anything like that. The whole open mic idea is community discussion, right? This is not, this isn't the Tim show. It's not just me and Don. It's anyone who wants to jump in. But I would say in terms of UAP, what I'm finding is more and more people, right? Like people that I had no idea they had an interest in this are starting to be like, oh yeah,
All of a sudden,
I'm
right? And what is that
yeah,
called? The woodworks? Like people are starting to get in,
coming out of the woodwork. Yeah,
woodwork.
exactly.
Yeah, no, I'll admit it, and I do admit it to even my advisors and my executives. Like, no, I'm new to the UAP arena, so in a way that should be interesting to some people, because that means that you guys are going to be getting almost an unbiased analytic delivery, right, about UAP. So I am still seeking guidance when it comes to, like, for instance, like NUFORC, the National UFO Reporting Center data. I could use some insight on that. What am I actually looking at? So I'm new to all of this. I'm new to UAPs. I'm totally was not, I didn't even believe it for a little while. My father and I even had an argument, didn't talk to each other for a little while because he said I was too close-minded. But even just opening up nuforc.org data alone has already compelled me to push further. And there's nothing that's going to change my mind. There's no doubt in my mind anymore moving forward with UAP projects. And
so Don, I'm going to paste a link in here in chat. And anybody who watches this in replay will have to request this link. But okay, so that is a full, basically it's a full download. It's a zipped file for what's called the UAP theory website. There was and I'm not sure you may have seen it. There was an Aguadilla, Puerto Rico sighting. It was captured by a U.S. Customs and Border Patrol plane in 2013. The video, they did chain of custody on it. They did all of that stuff to verify that this was real. What makes it interesting was it was a UAP. They saw it go into the water and out of the water. They also saw it appears to split in two at some point. It does some really interesting stuff. And this was all caught by a CPB plane on, official cameras and all that. So, and actually, Danny, I'll get to you in just a sec. What I wanted to say was a fellow named Thorsten in Germany created the UAP theory website where he did breakdowns of this, and he thought that he identified gravitational lensing and basically the signature of what you might think of as a warp drive, right? And so I just pasted a link into chat. The website is offline, but I saved that. I saved everything, the GIF files, the close-ups, everything. The Aguadilla video, actually, if you look it up, just try and Google SCU Aguadilla UAP video, and I'll find a link for a moment in that. The video itself is still online, but the work that he did on that, which appears to show the gravitational stuff, is off. And that's why I put the link in there. His website, there are no guarantees that it's correct, but he follows mainstream physics, and he was talking about modifying the geodesic. So it's really interesting. So Danny, go for it. And
yeah.
Can I get you to turn your camera on if it's okay?
Yeah.
Oh, there we go.
Is it yeah, the lights aren't great in here. Is this okay?
Yeah, no, that's fine.
Okay. So I really appreciate being here. I just wanted to, I don't want to take away from the discussion. I just, as someone had mentioned time travel, and that's actually something I'm really interested in. Just wanted to introduce my research, and if it was something that people were interested in talking about, it's definitely something I'm interested in talking about. So I authored the field of information physics called algorithmic topology. It models Turing machines as Hamiltonian dynamical systems. And one of the things I found is that there's a novel spontaneously broken symmetry that proves the conservation of information from conservation of energy in the inductive limit. And so I've been working with a professor, the chair of the materials science department at University of Tennessee, Knoxville, in a research group that's also out of ORNL, to create a novel metamaterial, a high entropy alloy that will be super paramagnetic, to create a radio frequency driven nanocavity that itself becomes an autonomous clock. And what it allows you to do is create these thermodynamically stable qubits. And what I want to do with those is do quantum machine learning at scale for the purposes of, I'm a very big Douglas Adams fan, and I want to create improbability drive using a homological model of time and quantum AI to recreate local entropic microstates and essentially entropic limit cycles in the laboratory, which would functionally be time travel, not so much like literal time travel, but would you really know if it was any different if the anyways, that's just the kind of stuff that I think about, and I just wanted to share that. That's it.
Yeah, no, that's awesome. That's awesome. I'd love, yeah, I'd love to learn more about that. I mean, yeah, so I mean, and so you've got a lot to unpack there too, because you're talking about time travel, you're talking about communications, you're talking about metamaterials, and then you're talking about quantum computing as well as machine learning, right? But yeah. Let me see. So Ross, let me go to you, sir. What's up?
Yeah, this kind of topic you guys are
Oh, Ross, you're breaking up, my friend.
You hear me?
It's good. Which something works.
You got me now?
Yeah. Okay. I sort of have you, Ross. I think there we go. Wait.
Yeah, I was kind of in a place where there was no reception for a second. But yeah, the two first guys were talking about time stuff, time travel and stuff. So that the guy that initially made the Mach 1 that me and Brian St. Clair are working on, he has a company that he calls it's called Time Entropy Incorporated, and it's in California. And but I just find it very interesting that it started off as just inertial propulsion, a spacecraft drive with inertia with gyroscopes, but it morphed into this time theory because he says while it's operating, he gets there's something going on with time, like clocks in the area or around the device seem to run slower or faster, or I forgot how he explained it, but I just thought I'd throw that out there and mention it. I've never told you all about that, but
Well,
the inertial propulsion machine seems to somehow bend time or do something with time around the machine.
yeah, I mean, he would want to, maybe there's a way to test that,
Yeah, how are you measuring?
Yeah,
Yeah,
and the best way to measure it would be if you have synchronized clocks, even if they're not perfect, right? Even if they're just close, have one like near the machine and then one like, in another building or out in your car or something like that, and then just compare.
yeah, me and Brian St. Clair, we're going to plan on doing that because that was really kind of a weird thing when Mike Marsden threw that out at us and let us know about that. So that's something we're going to try to test for in the future. But as another weird thing, in the center of the Mach 1, he says there's some kind of a singularity in the middle that happens in the middle of the device. And when he'll smoke a cigarette and he'll blow smoke at the machine and it like just disappears. into this weird singularity that's at the center of the machine
So
while it's operating.
I mean, for something like that, I don't know. Yeah, that could be an electrostatic thing too. You know, I used to do smoke testing. If you have a static field, that can make this, it doesn't actually disappear, but like if you have like a static field, it can attract the smoke to it and pull it out of the air. So
Maybe, but he's saying that it's literally like, I mean, even the air in the room, like he has to like open the windows because it's like sucking the windows inward, and the doors go inward, and it's like air is just like disappearing into the center of this machine while it's operating, only while it's operating. Like there's like this weird singularity that's just like a bathtub to nowhere, and it's like air just flows into it.
yeah,
And he can't explain that either. He has absolutely no clue.
so
It's weird. It's just really weird. So
you got like some video and stuff like that of it, or
Mike Marsden doesn't remember. Like I said, he's being really secretive with us and hasn't been really sharing too much. But he just mentioned it, so it's something me and Brian are going to be testing for in the future when we get our machine, you know, built better. We're building Brian St. Clair is building a second one now that's much better than that hunky steel massive machine that you saw him demonstrate last week. He's making it all super lightweight aluminum, super lightweight carbon fiber, titanium bolts, like he's got a lathe, a mill, all kinds of CNC machines now. He just put so much money into this. So we're full throttle this time. We're going to make a good, better, lightweight, stronger Mach 1. And so now we think we're going to get into the territory of seeing this kind of weird, wonky stuff that Mike Marsden has been seeing.
Yeah. I think it would be awesome to set up tests and see if he could document that. I mean, because one of the things, especially with time stuff, right?
Yeah.
The problem is especially when you're really focused, like your perception of time and space changes a little bit. So, you know, that's the kind of thing like Jeremy was saying.
Mike Marsden literally says his body feels different while he's around the machine and while it's operating. Like it's just, he can't explain it, but he feels like something. I can't remember how he explained it, but it was like he just said something with time is changing. Something with time around the machine is not right.
Yeah.
Me and Brian won't know until we finish our second version and get it up and running. And
I think that's awesome to test. I think that's awesome to test. You guys can probably, it sounds like you guys can do a lot better qualified testing on it than he can. And then because there are two of you, right? You guys have different versions of things. You can kind of do replications of it. And yeah, it's hard to tell. There's so many perceptual changes, especially something like time, right? It's impossible to know without actually doing measurements on it, you know?
Yeah, and how you're doing those measurements.
Yeah, I just wanted to throw that out there. Because the two first guys talked about time, and I had never even mentioned to you all that Mike Marsden owns a company called Time Entropy. You know?
Yeah.
So he's obviously interested in time stuff as well.
Well, yeah, let me go to Mark Fiorentino, if it's okay. Mark, go for it, sir. You had your hand up.
Well, since we're talking about time, one of my favorite subjects, I'm really interested in anybody who is using metamaterials, and in particular fractal lenses, if you're using those at all, and are you using them to accelerate light in order to bias space for the purpose of opening a portal? We're really talking about time travel. There's two different types: the changing of the speed of the clocks, how they measure, or the other one, if you want to jump physically to a different segment. So as I understand it, we're in different time segments, and these segments are very definitely related to space. Time in general is strongly connected to space. So and it has to be a physical connection. So of course, space has to be a real thing that is modified. So I would imagine in order to create a time machine that actually can open a portal, you're going to have to affect space, bias it with a faster than light or a pulse of some sort to tune to various spatial frequencies. Is anybody working on anything like that, the people that are doing time research? That's my question.
Yeah. Well, and let me go to Danny Cohn. Danny?
I'll turn my
There we
video.
go. Okay.
Yeah, sorry. So actually, I am working on something kind of similar to that.
Well, and maybe Danny, if it's okay, because you kind of started us off on this, maybe you could kind of explain more about what your model is and the homologous time.
Okay, homology. It's hard for everybody. Everybody hates homology. Everybody hates holes because they're really hard to think about because it's like the absence of something. But so essentially, what I wanted to do was try and create the fastest computer that could ever be made. Like, what is the fastest computer that could be made using the standard model? And the idea that I came up with was using quantum retrocausality to update the successor function of a Turing machine. And when you do that, effectively, you've created a time machine. And so from that standpoint, I started looking at computer programs as time travel and looking at the time-space trade-off as being literal. Like if the universe is computational, then time travel is about reproducing certain entropic conditions. And it's not so much that we have actually gone back in time. I think that time may not exist in the sense that we think it does. You know, we already see from relativity, there's not an absolute notion of time. So if you start to look at time as an ordered absence, as like something occurring on an expansive cylinder, which very much is what we kind of see when we look at different slices of large views of the universe. I don't know, it kind of fits. It'd be something that we could actually build at the laboratory and try if we had a WIC transducer, which is the device that I'd hope to build using this metamaterial. So that's kind of the short or long answer, however you look at it.
Yeah, no, I think that's really useful. So time is a cylinder then, and I've seen different descriptions of that in the past.
Mm-hmm. Well, I mean, it could. That's honestly a cylinder. That's a really simplistic. I mean, It could be some kind of multi-dimensional cylinder, but it's very much cylinder-ish in that sense, or maybe even pyramidal. But if you multi-dimensional holes are really hard to talk about, which is why nobody likes homology and everybody uses algebra. But really all I did was it started with trying to understand what essentially became quiver theory on directed graphs. I was looking at, I call it flow algebra, and imagine you've got a bunch of rivers and you place a bunch of rubber ducks on different parts of the river, and you say, after a certain amount of time, where do all the rubber ducks end up? And you're essentially looking at how information, which is the rubber ducks, flows across a conserved potential, which is these gradient networks that's given by the potential energy due to gravity. And so I applied that same math to directed graphs, and turns out it also works for computation because it's the same math for the exponential generating function for whatchamacallit. Shoot, what is for the natural transformation? That's what it is, the category theoretic term. So you're looking at combinatorial species. You're modeling algorithms as bijections, like essentially looking at an algorithm as a topological statement, and an algorithm is something that you can measure by the amount of information it moves at each step. And then like the whole universe becomes computational. And so you're just kind of applying that model to really standard stuff. And that's all I've done.
Yeah, no, you're very math intensive. I mean, you know, I'm following some of what you're saying. So, yeah, I'm following some of what you're saying. And the rubber ducks thing is interesting, actually. I've heard of that in the past before being used in relation to time. Yeah. Instead
Oh,
of
okay,
measuring
cool.
like, instead of measuring discrete units, you're measuring basically averages, right? It's like the average, you're averaging
Well,
things
so
out
it
kind of.
depends on if you're looking at the killing factor. It depends on which metric you're using and whether you're talking relativistic or statistical mechanical or quantum mechanical. All these have different notions of time. Newtonian relativity is Galilean relativity. Newtonian relativity has a very absolute notion of time. Then you get to Einsteinian relativity, and you've got a very different notion of time. And then you take it all the way to quantum field theories, and now things start breaking down in terms of analytic definitions of time, because a quantum field theory isn't a mathematically well-defined device. I studied algebras, a lot of the mathematical physics of algebra. So if you look at quantum field theory as a statement of algebra, it's not a well-defined device. So then you get into what is a Feynman integral and all that kind of stuff. And the long story short is intrinsic complexity is a topological statement about how disentangling algebras, you're looking at different commonalities in the Dyson ordering of a path integral, and how it can be applied to statistical mechanics, and how it's the same both in a quantum mechanical setting and a statistical mechanical setting as it's related by the Wick rotation. And that's, I just took a number of these commonalities, and somehow there was a theory behind it that was coherent. And
Well,
that's all.
But you're looking at this for computing, right? Now, is there a way to
Yeah.
communicate or travel potentially through time, or is that something
I think
completely different?
well, that's the thing is, I don't know. I mean, sort of. It seems like if you looked at computing using quantum retrocausality, every program that you built with that computer is effectively some form of time travel. Because the end result is you have created something where the prior conditions lead to the current state. So if you create a cyclic program, you have then created where you want to end up, and that could be a moment in time. And so effectively, yeah, it kind of is a time travel device. Now, whether that means you could go back and actually affect your own timeline, I don't know. I really don't, but you could recreate what it was like, maybe locally, to see the beginning of the universe.
Okay,
Whether-
well, that reminds me of, so I had read about a ring laser time travel experiment. This is years ago, but basically, and I don't remember the exact specifics, probably folks here have heard about it. The idea was basically a laser that was refracted into kind of a circle. And the theory was, I don't remember what see, Mark's nodding his head, he's probably heard of this. The theory was that you could send signals back in time because the photons keep going around in a circle, and so you could communicate back in time, kind of like what.
I'm sorry to interrupt you, but I actually did a report on, there's a relativistic version of this experiment that doesn't involve a laser. And I've heard of this. That's not actually time travel, but if it started in a boosted frame, it would be time travel, because if you were to somehow magically start in a boosted frame, I mean, it's fine. There's actually a three-dimensional version of time, or I'm sorry, where you have 3 dimensions of time and 1 dimension of space, and it's perfectly fine in relativity, and it leads to a consistent quantum field theory. But it's essentially just 3-dimensional physics in the boosted reference frame. So if you're going fast enough, it's not really that much of a problem.
Yeah. Well, let me go to Mark, and then actually I want to come back to Paul Mendoza real quick. But Mark, go for it, sir.
Yeah, your vision, the ring, is very close to what I hear they're actually doing. That's the government, U.S. government, from what I've heard in my contacts. And that's why I brought up the fractal lenses, because what they do when the light is beamed into these type of devices, which is basically a metamaterial. And if you go to ResearchGate, they talk about these metamaterials and the trick, what works for them, why they're good for time travel, is that in a metamaterial, if you shine light into it, it accelerates beyond the speed of light to infinitely fast. And they're claiming this on ResearchGate. And so there's a big argument going on between physicists that that's not possible, you can't do it. but these guys say they've measured it somehow and proved and verified that the light is going ridiculously fast. And the advantage for this is once you release that light beam out of the framework, the ring, into space around the fixture, it's going to come out highly compressed at frequencies that are beyond anything we've ever generated. And that's how you tune the space to open the portal. You have to cause it to vibrate really high frequency. And you use that maybe in conjunction with some sort of sound, frequency sound, and also ultrasonic along with that, and you project that from the fixture, and in so doing, you can create a portal opening. To do the other type of time adjustment, with clocks moving faster and slower, that's again, you use special relativity equations and stuff, and you realize you can slow time down with gravity, and you can speed it up, which hasn't been calculated yet or realized yet, by using electrostatic fields or high intensity magnetic fields. And it's all got to do with messing with space and the two properties of space, which are permittivity and permeability. You drop those, you're gonna have an amazing effect on your ability to project light through that material. And that's what they claim they've done. They've dropped the permittivity and permeability within the metamaterial to 0. And if you calculate that using Maxwell's equation, C equals 1 over the square root of permittivity times permeability, you'll find once those two properties of space drop, the lower they go, the higher the speed of light. It's all out there. You just got to piece together the evidence that's there, and then put together a fixture of some sort that can do this type of work. And it's great because you can tune it to different times and portals. That's the rumor that I'm hearing.
Yeah. Well, thanks, Mark. So let me see if Paul Mendoza in chat was talking about operations management for neutron star systems. Let me see if Paul is still with us. Yeah, he's still here.
Hey, doing,
and
Tim?
Paul, yeah, hey. So you were talking. Actually, Mark had followed up on this. You guys were talking about doing electric propulsion plasma thrusters, basically a magnetoplasma dynamic. Could you describe that a little bit? Because yeah, that's totally right up our alley. That it's been around since the 60s, but it is alternative. So
yeah, I think what we're doing is pretty unique, actually. So again, are you familiar with electronic propulsion? I imagine you guys here have some idea, right? So generally this is used for like station keeping. It's a very low thrust, high efficiency motors. And essentially we're taking a gas and ionizing it. So we're using electron bombardment to create the ions. And then basically our hook is we're using the high temperature superconductors to create a very strong electromagnetic field around this plasma in order to accelerate the ions and generate much higher thrust. So one of the unique things that we get out of using the high temperature superconductors is that we are propellant agnostic. So current EP systems are using xenon or other really expensive gases. Our system can operate on argon, hydrogen, methane, essentially any sort of gas. And so we're working on a number of different thrusters. It's scalable. So we have low thrust all the way up to 100 kilowatt scaled versions. And we're also working on a system that is, we call it multi-mode propulsion system. So we have basically a conventional rocket integrated with an electronic propulsion system operating on the same fuel tank, using the same nozzle, the same propellant, and we can basically flip a switch, go from conventional rocket mode for high thrust, and then switch it into EP mode for high efficiency. So again, neutron star systems is originally based out of Germany. Now we've opened up our US division. We're targeting contracts with Space Force, Air Force, NASA, this sort of thing. So it's really, yeah, really cool stuff. It seems like you guys are talking about some really advanced, crazy things too. This is all really new to me, to be honest. My background's actually in petrochemical, oil and gas. So I'm new into this industry. So I'm trying to get caught up and just, attending webinars, listening in, meeting people, and trying to get myself oriented with this industry now.
Oh, awesome. Awesome. Well, thank you for joining us. Thank you for popping in. Yeah. I mean, ion propulsion, that is definitely part of this, right? It's really, I think the focus of APEC, what we try and encompass is everything that's kind of beyond chemical rockets. And to be honest, we do some conventional stuff sometimes too, but it's just, it's kind of like, what else is out there, right? What's coming next kind of a thing. So.
Absolutely. I think this is one of the more likely technologies to take us, interplanetary or lunar. So our multi-mode propulsion is ideal for targeting a lot of the lunar orbits that are out there that they're looking to target, essentially. So
yeah. Well, Paul, thank you. Thank you very much.
I don't have anything prepared for you guys. I could, have slides, thing, but I just jumped on and kind of wanted to see what the APEC is about. And it seems really cool. You guys are talking about some really interesting stuff here.
Yeah. Well, no, thank you. Thank you very much. It's exciting, right? And it's all like new technologies, and the time is definitely right for it. So let me go to Drew. Drew, I see your hand up there, but Paul, thank you again, sir.
Hey there.
Hey, Drew, long time. How are you doing?
I'm doing great. Got some exciting news to share, but Rudolph, just wanted to ask the last presenter, what kind of power to thrust ratios are you having? I mean, is it like 100 watts per? Let's say you could scale up to a Newton. Is it like 100 watts per Newton, 1,000 watts?
Yeah, actually, if I could share my screen, I could pull up.
Yeah, go for it. Go for it.
Give me a minute. I'll have to find all my graphs and everything, but I'll get back with you on those figures.
Oh, okay. I was just curious. Well, I can go ahead and share my news. We broke 24% thrust to weight ratio today. So we're still in the single plate, just playing around with single plates right now, but we're up to 24% thrust to weight ratio. So we're generating about 2 millinewtons of thrust on something like a gram of material now. So and
That's awesome.
we're fully scalable. So we're really excited because the goal is 25% thrust to weight ratio, so that we can so that our debut vehicle, instead of just going up and buzzing around low Earth orbit and I don't know, buzzing the space station or something, we're dreaming about actually leaving low Earth orbit and heading to the moon and doing a soft lunar. We don't want to call it a lunar landing because we don't ever actually have to land. So we're just going to kind of go and do a lunar hovering and kind of buzz around and have some fun on the moon and then bring it back to low Earth orbit. That's the current dream now that we're closing in on 25% thrust to weight ratio, which we should be at hopefully by tomorrow, because we've got a lot of exciting things to play with. So anyhow, it's really cool. Again, for those of you who don't know, my team, Exodus Propulsion Technologies, we've got our patent is out there now if you want to go and read it. But it is asymmetrical electrostatic pressure. So basically it is the Star Trek impulse engine. You put in energy, very, very small amounts, and you get out actual thrust.
Yeah.
I'm trying to lower my hand here, but I'm on my cell phone.
Oh,
so.
no, that's okay. Drew, I can lower it for you. Thank you. And then I should ask Dawn. Dawn, did you want to do a screen share, or are you still working on it?
Actually, sorry. Can I interrupt? Dawn, this is Dawn Tadaya. I'm sorry. Can Drew share or Andrew share a link, or just tell, or if anyone has an idea of what the website is that he's talking about for the company, just share it. I really would love to check that out. That sounds.
There is no link. We are completely stealth.
Okay. Would love to connect with you. Yeah.
There is nothing aside from our patent, which you're certainly welcome to go read. There is nothing else to share.
Absolutely. No, that's okay. I would definitely
connect
offline. Thank you.
Well, let me get, actually, if it's okay, let me go to Dawn EM really quick. So we have a bunch of Dawns with us today. It's getting confusing. Dawn EM. Okay.
Thank you. Sorry. Am I on yet?
Yeah. Yeah.
Okay, very good. Welcome to my attic. I've been orbiting around this group, all the groups, for years. How's my volume?
Yeah. No, you sound great.
Okay, very good. I just had life events compelled me into seeing time differently. And it seems to me like time slows down if you slow down the quantum or modify the indeterminate period of your quantum oscillations. That makes everything, which is right back to the 1950s W.B. Smith technology of magnetic coupling, phase-space coupling into the nuclear waveform to get the UAP effects, because I think we can knock electrons around till the cows come home. And we're not going to be bending time much, but there's exceptions to all of that for sure. But what I'm trying to get to is the proof with a ring oscillator that has very fast transistors energizing, like I believe you were referring to in the chat column, a group wave effect. I want to bring a copper element to nuclear magnetic resonance, or just above, just below the resonance of copper, to derive a bismuth sample that's more sensitive into resonance, so that the system, when the noise is analyzed, will have the signature of the bismuth nuclear effect on there. And with the proper algorithms, which are a bit beyond me, someone could take that noise spectrum and basically do a sonogram of the womb of the atom, basically the inertial response dynamics as it affects the coherent waveform that I hope to resolve. Now, to get some UAP effects, I agree, we got to slow down time. Bob Lazar said, when you're right under this one UFO he saw levitating, he wasn't sure if it was the one they dug up, which floored me. Oh, I'm twiddling my mic. But he said, if you're looking at it, you don't see it till you get right under it. Time, when it's bent, bends the shortest travel of light, and the straight path for light is the least time to get there. To bend time at the quantum level, what are we going to do, and how would we ever do that? I personally struggled a long time with it. The way I want to try to test it is by throwing a macro quantum resonance up, by basically getting a group wave effect of quantum coherent resonators, which bismuth is the best, has a 9:2 nuclear ratio, so it's got some odd elements sticking out, and it's quite couplable. Where I got this was a disclosure. I assume it's 1980s technology, pending the guy's age and when his family corroborated stuff like that. But the information to put it together came from an autistic mind, and it's been really tricky to get my head around this. And then I sort of pop in here and we have this time topic. So I just like to close and say, I'm looking for, I will help anyone build what I've reverse engineered. And as you can see, my house here has me on hold. We lost our whole roof to a dirty contractor. So here I am in the attic. So I can't get my bench going, but I really have this urgency to do this test to try to slow down the remediation of electromagnetics by cohering with the quantum waveform, which messes up its normal contribution in slices of time, discrete quanta by discrete quantum, to make what we have as our electrodynamic effects. Every electrodynamic force is based on a duration of time. If you bend time, you've bent the unit of measurement, and it's not what we thought it was. So, well, yeah, go right ahead, please.
Oh, well,
Signal
Don, I was going to say,
I think
so
is what it's about.
Mark Sokol has his hand up, but I was going to say Mark might be the person to talk to about test stuff also, because he has a lab.
Yes. Well, can I, Mark, let me click in before you get started, though. May I?
Oh, Mark is actually, Mark has an experiment going. I didn't know that.
Oh, well, I think
it's not turned on at the moment, but Don, I think what you're describing of using a copper covered in bismuth sample inside of an NMR machine. What you're looking at on my screen is basically an EPR machine, electron paramagnetic resonance machine.
Okay.
And the copper tube there in the center, it's actually a piece of 1-inch pipe. And we have it set up as a TM transmagnetic 110 resonator. But it also has the ability to weigh not just weigh the sample inside, we can weigh the entire chamber. Because it's on a pivot. So there's actually 2 weight measurements. The weight measurement on the left there that keeps on changing, that's the weight of the 1 gram sample. And then there's another scale that I think is disconnected right now, but that will show you the weight of the entire test chamber. So basically,
is this you speaking, Michael Boyd? Is that you?
No, I think Michael's there too. I think Michael is patiently waiting. Michael is
speaking?
patiently waiting. That was
Okay.
so that's Mark Sokol, and Mark is actually in his lab doing right now.
Well, I just want to close quick, and then I want to collaborate with the first guy that spoke, because I wrote a proof for the former Soviet Union's spook code that was imported into DARPA in a 2000 BAA. And it's a category theory, and it's just going to be really good for looking at the timing jitter on a ring oscillator with the inductance flirting with the nuclear magnetic waveform. So we're going to see a dimple of an effect, and that dimple is what I want to lay the wattage into. I think this thing should be built at least around 1,000 watts. So it's a nuclear magnetic resonant experiment. I've got what's called quasi-axiomatic category theory and paradigm that I'm putting upon it, which is basically analyzing a stream of timestamps. In effect, gives you a visual abstraction.
Okay, well, and I think so Mark, hold on just a second. I think he was talking about Danny Cohn, right? So Don, you were talking about Danny Cohn, right? I think that you wanted to collaborate
The first
with?
guy that spoke was the Don Tadaya.
Oh,
and his
okay.
Gassian, his company does analysis. And I think he might, there's nobody knows this code that I had to write. It sort of scratched my brain apart 23 years ago. It's used in, the TIA developed it. They got it through a triple PhD in the Beltway. And it essentially is looking at all the information patterns in the world, and it can get the ripples in the wheat field and isolate them back reference to the telephone it came from.
You know, well,
it's pattern recognition on the whole world. The PhD called me 10 years after it was started, which probably put it out of classification. And he says they structure the language of the whole world to the moment.
Yeah, I would say, Dawn, I mean, if you're open to it, maybe drop your email in chat or you know, or Dawn EM, or one of you gentlemen, or both of you gentlemen, drop emails in chat.
And the paradigm's so simple. I'm sure you guys would be interested in it. All I need is to be able to have enough human contact long enough to figure out how to communicate. Thank you all very much.
Thank you so much, Dawn EM. That's great. I'm messaging you my personal email address right now. I would love. Feel free to share with me any literature. I have a deep obsession and affinity for data. If it's clean, I would praise you, but I'm used to working with dirty, with messy, unstructured. So, you know, feel free to. I would definitely love to collaborate with you. I'm currently collaborating with Mark Sokol right now as well too. So, yeah, feel free to reach out anytime. Thank you.
Yeah. Well, and so speaking of which, let me go back to Mark. So Mark, do you want to describe the experiment a little bit more, or? I didn't mean to cut you off, buddy. Okay, let me do that. And actually, I'm going to use the restroom really quick. I'll be back in 2 seconds.
Yeah, I was actually curious about Mr. Don EM, the guy that just spoke's potential experiment. You said you wanted to play with the nuclear magnetic resonance ranges. What exactly are you hoping to achieve there? Because we're doing something very similar here. And we have all the equipment set up for it as well.
Well, I can buy a ticket. You're on camera, honey. That's my wife. I can't sing. Sorry, guys.
Yeah, I think we'll have fun together. But Don, so basically we're dealing with, you're talking about NMR on a sample that has bismuth and copper together, and you want to do something that's a little off the NMR frequency.
Yeah,
that's very interesting, because we're doing the same thing with aluminum but we're trying it with EPR, going a little bit off the EPR frequency to there's a forbidden transition that transmits the orientation of the electrons into the core, into the subatomic particles in the core. And that brings up a state called dynamic nuclear orientation. And with electron paramagnetic resonance, you're actually able to do both EPR and NMR simultaneously. And the nuclear magnetic resonance feedback is 1,000 times stronger, 3 orders of magnitude more powerful when you have an EPR going on simultaneously with the NMR.
Wow.
Yeah, so we already have that all set up over here. And if you look at my screen, you can actually see a spectrum analyzer. The equipment's not turned on right now. It's just showing you
Where are you located, Mark?
We're in Hawthorne, New Jersey.
What you can get here is some IP that nobody knows about. The scientists wanted me to do a n-dimensional display of category drift in the occurrence density of individual categories, and you can stratify them out and blow them around. You can do multi-channel, switch them in. It's sort of like scanning a CB for the nuclear signal, just by doing a time-aligned matrix of all your sensors, so that you're comparing apples to apples at the same moment in time, because you're trying to find the phase space, and you really want to get that on a nut. With this, I've got some hacker tricks to throw at it. Basically, I'm timing each segment, and it's a segmented oscillator, and the segment completes by meeting a threshold of the current that triggers the next segment. So with that threshold, you can essentially tweak the puppy in to where it's an auto-resonant array. Then you can tweak the natural resonance of it when it goes magnetic resonance by a biased current on it, which is your B0 current of your NMR, right? So you basically, when you magnetize copper paramagnetically or an odd nucleon element, when you magnetize it, it's precessing and it sticks out little magnetic handles for you to couple with, right? So that's why certain resonance do that. So what I want to do is get a copper element at resonance and drift that back down or up to cross over that and map out the profile. Because what I really want to do is exactly what you're getting into. You may be a wealth of information, and I think together you could get some spook code analysis going, and that's what I plan on doing. And here's some IP that I can claim for the record. This quasi-axiomatic theory takes a combinatoric expansion of categories between 2 measurement columns. Now, that combinatoric expansion is time involved when you're doing it on a world full of data at the same time. We used a 1 megabyte sample of a DARPA log, looking for terrorists by the number patterns. And by the way, my machine does it today 20 times faster than the DARPA proof did. Oh Lord, I think I lost my train of thought. Any questions, class?
Yeah, what is these groupings that you're talking about?
Okay, the group, you know what, torus knot, people know torus knots. A 3-2 torus knot, it's not a trefoil, it's a knot. It goes around, it goes through the hole 2 times to get around the torus ring 3 times, right? So the helix is sloped. That happens to have bifilar, it's in half at the opposite sides. You can cut it in half at the opposite sides and you got 2 equal lengths. Well, they also go opposite directions, they're opposite helices, and it makes a weird mix of addition and subtractive kind of coherence. It makes a very messy thing, and what we're after is all the mess we can get. And when you get any kind of nuclear standing wave on a variable topology where you don't have a what do they call it, Mark, when it homogeneous, then your magnetic sample is ringing at a whole lot of frequencies, but that's also what stands up in a bugle horn. So we're actually trying to isolate and make ring the inertial moment of these things, because we're oscillating against themselves. If you can isolate that signal and get it amplified strong enough, like Mark was saying, and they've got that exciting advancement there. What we really want to do is map it out and put the data to our first speaker.
Oh yeah, that's what we already did. I could share with you, this is some of the data that we have. And what you're looking at is, these are weight measurements over time. So what we're concentrating on is these little blips where suddenly the weight of the sample like drops out like crazy. And
you got a weight change.
Yeah, yeah, and in some experiments we saw lots of blips, and some of them we saw almost none. And over here on the right, I have descriptions of what was changed in each experiment. So
if you slow down time, weight changes.
Well, we're just measuring.
What I'm saying is, it could be just as easily a time anomaly as it is a gravity weight change anomaly or mass anomaly.
Well, we're looking at what you're looking at over here with these squiggly lines is the weight of the sample over time. Normally, they're about 75-minute runs. Some experiments are slightly different, and we're starting at about 2,000 Gauss, going up to 4,900. Every single experiment has its little description over there. So this was 2,000 to 4,940 Gauss. So that's about, and that time duration is about an hour and 15 minutes or 75 minutes. Wow. Don already has all of this data, and I think he's gonna be looking it over to try to, learn from the data to advise us on our next setup experiment. But I found what you were talking about pretty interesting. Mixing copper and bismuth together.
Yeah, the copper just floats down and touches the bismuth, and the bismuth imprints its signature. Now, this ring amplifier amplifies things at a similar periodicity, and it averages out anything that's aperiodic. But you got all your heterodines in there in the middle, right? So your sampling rate on this. See, when it comes out as a time stream, all you got to do is take a few samples. It can be running 610 megahertz. You can still take a few samples of the time periods. It's a fractal analysis, so you can get a resolution, and the more sparse your sampling is, then the longer it takes to get resolution on your waveform. So, and there'll be sweet spots in there. And I think most of it can be done in a balance of 4 bits, maybe even 3.5 bits with a controller that's 4 bits, because we're talking about radio frequencies, and I don't want to have to map something out at gigahertz rates. Anyway,
I'm already doing that. It's a lot of fun. You can see a lot coming back from the signal when you're dealing with gigahertz frequencies. As the sample moves around in the chamber, so this oscilloscope is showing you the reverse power coming back from the chamber. If the device was on right now, you'd see lines all over the place. And if I were to turn the sample slightly, you're actually able to see that the reverse power changes, like it shifts left and right. That's because it's critically coupled to the chamber, and anything that's in the chamber throws that out of whack and starts sending you back signal. That's how they get an EPR signal.
With that much energy in it, you're going to have some drift frequencies, and it could, Lord knows, be like a super wave could come along eventually in the drift.
But the drift frequencies, you need to really expand the spectrum analyzer to see those. I do have 2 spectrum analyzers just for that purpose. If you want to see drift, and they're all over the place, and there's almost no way to get rid of them because you're right. They're so freaking sensitive.
I want to share with you this one thing. This gives this technology approach, this magnetic pulse thing, just overdriven magnetics that comes to their own harmony that's not there by the system, because you're driving them way past their coherent place with more energy than is even their coherent state, and they're all full of random energy, and they will glom onto the nearest strange attractor, right? So this field array, when you make it bigger, I might be drifting. I think I am drifting. Did I get anywhere close? Over.
Yeah.
Sorry about that.
Yes, over. I got the ham radio reference as well.
Okay, I've said plenty. I look forward to connecting with a lot of notes. I took my website offline since I've broken through and I know what I'm talking about.
Well, Don, maybe, again, I'm not sure if you put your email in there, but definitely drop your email in.
I've already sent an email to both Don and Mark.
Oh, okay, good. Yeah.
Oh, I wanted to mention there's some IP to bring out here that could pay for some stuff because the combinatoric expansion will unwind the loop and put it in parallel on an FPGA. And we'll be looking at category theory images at real close to radio frequency rates, at least with sparse sampling, and over time we can get some nice resolution.
I'd really like to see a picture of your apparatus.
It's a donut with
that's what I'm saying. So you're saying that you have a ring emulator. It's like a ring. You have a ring.
It's embedded. I'll get it all to you.
Which is really fascinating. I'm interested.
It's a self-segmented array.
because there's natural symmetry there by just the simple basic the structure.
I can pop your brain on Fibonacci and torus knots and golden ratios.
No, I get the fractalization that you
can put a knot together that has no everything is a power of the golden ratio except for the knot helix, and that's the Fibonacci numbers approximating a golden ratio.
Interesting.
Like 13.8.
Yeah, interesting.
Awesome.
So there's nothing in it that actually has anything square. So I don't think there's going to be anything but an antenna that pushes a bunch of electromagnetism with a totally broadband spectrum on it. Not to mention you have your trumpet horn effect of all your windings separating out towards periphery compared to the middle. So you're going to have an ability to get a non-homogeneous nuclear magnetic resonance set up that'll have a resonance spot somewhere on that torus. The question is, we got to detect it the first time so we know what we're doing.
Yeah,
and it's going to be a little like putting those magnetic shims in the back of the electron gun of a picture tube.
Literally the same problem that Mark is having, but in a completely different set, like a totally different setup, and sample as well. Mark has been thinking about samples and trying different things and trying different shapes too. So yeah, that's
I think it's awesome that you guys can, if you're able to collaborate, that compare notes.
Literally I just sent a collaborate. It said collaborative on the subject line. So we're way ahead of it.
So let me jump to Michael Boyd, who has been patiently waiting. Michael, welcome back.
Hey.
Long time. No, I saw you on Bernie's channel, so it hasn't been that long. It's only been a month or so.
Oh yeah. Bernie's channel's a blast.
Yeah, I have fun with Bernie too. He has this infectious sense of humor and optimism,
Definitely. So I'm working on, I've been probably got a couple of my emails about I'm working on a paper for IEEE called Resolving the Extra Dimensions for Gravity. And I went in the chat and I put my email and I uploaded my most recent revision, Rev 4. And I would appreciate it if somebody could go look and see if they can find it. And if you can't, let me know and I can do it again. And so what the paper's about is below 100 nanometers, the force of gravity is magnified. And it's there's two dimensions. There's an anti-gravitational field and a gravitational field. And so what I'm proposing is that I have data to show evidence of that fact, and that is, in fact, accounts for things like dark energy. This nano anti-gravity accounts for dark energy. And dark matter is basically this magnified gravitational force. And so basically there's three what I call wave particles. There's the photon, which we all know about, which is massless, but most people don't realize it's timeless. It doesn't experience time or it doesn't experience distance. And that's why the speed of light is constant, in fact. The other dimension is gravity. Gravity is time dependent. And so the quasi or the particle wave is called a graviton. And it's what's called a massive wave particle. And then there's an anti-gravity that's produced by the absence of matter moving, and that's a massless, time-dependent wave particle. And so in the paper, what I'm trying to do is address other current theories that seem to apply to that. And I found this one by Harold Halputoff, who he proposes a space-time metric engineering paper that I'm referring to, and I contacted him on LinkedIn to make sure it's okay to use his name on the model I'm using. So if you guys are, what I'm looking for is I'm looking for review, I'm looking for comments, I'm looking for criticism. And I'd like to give a nice long list of acknowledgements when I submit it. And so that's basically with the project I'm working on currently.
What's a wet wet?
Okay,
Awesome. Thank you.
sure, thank you.
Yeah. And Michael, let me see. Did you put your email in the chat? I mean, if
Yeah, I put where I
Okay.
put this document in the email,
Yeah.
I put my email address too.
Oh, from the air conditioner.
oops. Oh, sorry.
Air conditioner.
We're getting some back.
So
Hang on.
somebody confirmed that they got it. So it
Yeah,
looks like
okay, there we go. Yeah, sorry, we're getting background noise. Yeah, and just a reminder to everybody, if you're not talking, just make sure to, blank things out or mute yourself out. Michael, thank you. And
Thank
let me
you.
see. Let me go to Michael Ryan next. Sir? Hey,
Hey, hey, do you see me?
yeah, you look great.
Cool. Hey, you're a hell of a host, Tim. I've been watching you since the American Anti-Gravity days. I was kind of a fan of Jeremy too. I've been lurking for many, many years. I got my degree in physics. I work as an engineer currently, a government contractor, machine learning engineer at the moment, and I work with acoustics, mostly for underwater stuff. I had been developing works with general relativity. I was a practitioner, and I found sort of a new approach to its relations to electromagnetism. It deals with more like a Riemannian electromagnetism, and if you know anything about like the GEM equations, like gravitomagnetism, you know that it derives directly from general relativity if you do the linearized gravity approach. The idea was that there was some kind of true electromagnetism, which was also Riemannian, and you could derive Maxwell's equations from that. So that was what I worked on. That's not what I'm here to talk about. That's an old thing that I could not make it work. I found one falsifiable test other than propulsion itself, because propulsion was the only reason I was doing it. I had a kid. My life, it's more about work. I'm really more of an open source developer these days, and so you can check out my work at github.com /spacetime engineer. The reason I'm here is a little weird. I found something, and I just wanted to ask what you guys make of it. It's strange because all of the approaches to propulsion I have ever done, this was the easiest, and it makes no sense because it's classical. It relies on a non-QED, a more classical formulation or interpretation of Maxwell's equations, and I just wanted to see if I could present my screen and show you, if that's okay with you.
Yeah, go for it.
Great, thanks. I assume this is the right way. Do you see something?
There we go. Let me see. I see Gmail. Yeah, and it's the APEC Open Mic announcement letter.
Oh,
Maybe
sorry,
that's the wrong screen, wrong window.
Yeah, I picked the wrong screen. Sorry. Do you see? Sorry about that. I've never actually used Zoom before, so I'll share it one more time. This might be it. Sorry about this.
Oh, no, that's okay.
Okay. Do you see something that looks like a window, a simulation window?
Yeah, I see a graph. It looks like an electromagnetic. Yep, I see a simulation
okay.
window. Yeah, the open
I want to
stat.
show you something. This is kind of weird. It's simple, but so right here is a ring of current, right? And it's a very simple scenario. And I want you to imagine we can control this, like we can move it any way we want. And this is in one dimension. It's very simple. and I want you to focus right here on these are the magnetic troughs. So right here is a magnetic field. This is the magnetic field. So the red part is the magnetic portion. In this moment, at this instantaneous moment where current is coming this way, there's going to be a Lorentz force going sort of this way. I don't have the vectors to show you, and I'm sorry. But watch what happens when I animate. If you look carefully, it's almost like a duty cycle, or there's like a 4-stroke engine. Right here at this moment, we get propulsion in the same direction because the right-hand rule works at both ends of the ring such that they're in the same direction. Current's moving in different directions, and so is the magnetic field at each point. And so it allows it to move, forward. When it hits this part that we're hitting right now, the forces start to cancel out, which is interesting because, we have the Lorentz force working in 2 directions. There might be some sideways force due to this, but, it shouldn't be a problem. I speed it up, and what happens is I'm at another trough. Now, unlike the last time, the current's now flipped. It's going in the other direction. But okay, because the magnetic field profile is now inverted. And so I continue on, and it just keeps going. Now, what's weird about this is I'm violating momentum conservation, apparently, but I don't think it's the correct interpretation. I think what's happening is I'm taking momentum from distant sources, and that's the idea. I don't know if any of that made sense, but it's like a wheel or something. It's a way to sort of grip space. So if you know how a gyroscope works, it locks onto space in a sort of in an angular way, but not we don't know how to do that translationally. The problem of space I've
been working on that since like 1998, and every few years someone else comes up with the idea of the rectified electromagnetic field acting on the oscillating current. There's lots of variations of what you just showed, and that won't. It radiates in one direction energy. It conserves momentum, but it's no stronger than one rocket.
So that drive is idealized because it would have to move at the speed of light. If you watch the waveform, it travels quick. If you fix the waveform or the radius or the diameter, you'll get that Lorentz force. You're right about the radiation, and that's what I was trying to figure out. Because well, it just was weird because I couldn't. You are going to be how do I say? You actually don't have to spin it. You can also alternate the current, but the problem is that you're either going to deal with high frequencies that the material can't handle, or you're going to be dealing with a less efficient form of that particular drive system. Because, like I said, it's moving at the speed of light. You only get a fraction of that.
Well, you don't need it to be moving at the speed of light. You basically need the source of 2 antennas separated by a quarter of a wavelength, and they will basically interact like that and create a quarter wave reflector that essentially reflects all the electromagnetic waves in one direction and exerts Lorentz force on both antennas in the same direction.
Can you send me a paper where people have talked about this? Because
I wrote a paper called Warp Drive Propulsion and Maxwell's Equations back in 2001. Where I had an array of antennas doing exactly this, that the whole array was synchronized to move forward based on the interaction between the sources. And it can work, but as I said kind of before, it's no stronger, it's no more powerful than a photon rocket or a laser collimated in one direction. It's still just emitting electromagnetic radiation to make it go.
Yeah, and then I should mention, Drew Hempel posted in chat. He said, check out Sir John Pendry's research. He said he is ultravioleting conservation of momentum with Archimedes screw of light, circulation of light. So that's in chat. I've never heard of it
I
before.
have to admit, I do not believe anybody that says they violate conservation of momentum for any reason, but that's me.
Hey, I didn't say that. I talked
No, I
about
know,
apparent.
I know.
Yeah, no, sorry,
violation.
sorry.
Others there.
The way I see it is just there's there might be a small domain, because I don't mess around with momentum conservation, but a small domain in which the radiation you interact with directly. The thing that I keep thinking about that I don't know if you're seeing, taking momentum from it has more to do with the decomposition of the magnetic field. The real reason that the drive came to be had more to do with, I was imagining if we had sort of constant electric or magnetic fields to work with, which we don't in space. I mean, we might a little bit, but for the most part, they cancel. But I thought to myself, the radiation is everywhere, and there are unique radiation files everywhere. And but if it has strong current, but even the idea isn't that you're taking momentum from the photon, you're riding the photon. It's a kind of resonance. But that's all I got. It's related to EM resonance, and you would tune the phase in the drive controller to basically derive your propulsion if you could control it. You're right, though. The radiation, I can't speak on that. I haven't been able to model that yet. And, you know.
Michael, you should check out David Perez's work. It seems very similar to what you're talking about. And they recently achieved 475 grams of thrust at their latest test, using about 1,500 watts of power.
The radiation is the same as what you would get from the so-called hidden momentum.
Hidden momentum.
The magnetic moment across the electric field. And then you've got your gauge field and the charge, each contributing to the momentum. But in this case, and like you showed, in certain configurations, you can rectify it to give you a propulsion. It's just not very strong, and it's not going to exceed the speed of light. Now, what you were saying about if we had fields out there, you're absolutely right. If we had a Lorentz invariant magnetic field polarization to push off of, that was the same everywhere, no matter how fast you're going, you'd be able to go anywhere faster than light. But it doesn't. We don't. What we have is an unpolarized field that's the same everywhere.
So the polarization can be pretty easily handled if you just spin the ring on another degree of freedom, like with another, like a gimbal or something. So that's how you handle polarized waves. And there's also multiple degrees of freedom in which, well, there's multiple sources in which radiation's coming. But yeah. No, you're right. I mean,
every time you rotate, you're generating an electric field that's going to oppose the rotation and oppose the motion.
Yeah, that's true. But we don't care, as a general rule, we don't care if there's onboard power we're spending. We're just trying, this is not reactionless, by the way. This is propellantless, but it's not reactionless because it interacts with the open system. So that was the idea. So I'm just going to try to, I need to do a little bit more investigations into this, but there's not an easy way to test this unless I have like a Cavendish apparatus, or I can put it in low Earth orbit. I also don't have a spectrum analyzer. I don't know the frequencies I get to work with. So there's a lot of things a prototype like this would need to work.
Also find out that the smaller you make it, the less thrust or less propulsion you get. And if you want to make it so that it could lift its own weight, it's about the size of a football stadium. And
I don't think it'll ever lift its own weight. I think this is something that
I'm just saying it needs.
I think in the vacuum space you'll get some propulsion, but anything relating to anti-gravity, you're going to need something more along the lines of standing wave, where you're actually providing the waves that bounce off the Earth. It's sort of a similar technology, but anyway, that's all I got, guys. Thanks for having me, and it's really cool.
Yeah, well, thank you.
Yeah.
Yeah, no, Michael, I appreciate you sharing it. And I would say as your work progresses, as you continue doing more, if you have different variations on it, definitely come back, share more, you know?
Oh,
So-
yeah. I came here mostly just as a notice, just to introduce myself. I've been a little annoying. I got on Twitter. It's wicked awkward. But basically, there's just a lot of work here, and I'm really just I'm just doing my own work, and I'm just trying to share it. And it's really, I didn't realize so many people were working on so many cool things. So
yeah,
that's awesome.
Well,
just hope for the world.
You know, and if I could offer a thought, excuse me, sorry. I mean, back when I was doing the American anti-gravity stuff, everything was so scattered, everything was so out there, right? And people didn't talk to each other. And one of the things about APEC that seems like, I'm not sure if APEC is causing this. I don't necessarily think so. I think it's just the modern technologies and Zoom and things like that. What I'm seeing is all of these folks from different backgrounds with different ideas are like collaborating and working together, right? And like I'd mentioned to Mike, Michael a few minutes ago, Bernie's channel, you know, there are lots of different channels, there are lots of different forums, all that kind of stuff. But like what I see is this community coming together and forming, and that's amazing. I like, words cannot express how wonderful that is, because like it helps to have people to bounce ideas off of. And you know, there are just 100 different reasons why it's like many working together is better than just one. So yeah, I'm so excited. And that's, I mean, like the big reason that we're doing this open mic thing was just so people can cross collaborate, you know? And
yeah, well, thank you so much. Thank you, Todd, for your input. Nice to meet you guys. Very cool.
Yeah. And let me go to Phil. Yeah, Phil just popped on, and I was going to call on you anyway. So go for it, sir.
Sorry, I want to say something before you leave, Michael. I'm not sure if that applies in your case, but the momentum of a photon, I calculated that. I wrote everything in my book already. It took me some time to remember my own book, but the momentum of a photon, if you consider the photon as a mass, an equivalent mass, not like it's not a photon is not massive, but it has the equivalence of a mass. Then you can calculate the momentum of the photon more easily and things like that, since it has a mass. So it's kind of different mathematics, but you get the same results, but the concept is a little bit different. So maybe that can help you out if that applies in your case. And
thank you.
Yeah, I can send you a free copy of my book if you want.
Oh, thank you, Phil. Yeah, I sent my email. I'm spacetimeengineer@gmail.com. So, you know, whatever way you want to connect, you should be able to find me.
Yeah, sorry. Can you paste it again in the chat, because I reconnected 2 or 3 times.
Of course. How's that?
Thanks.
No problem. Have a good day.
Awesome. Thanks.
Yeah, awesome. Phil, thank you as well. Let me go back to Todd. Todd, I see a hand raised. Todd should I tell the story about your picture? He has a microscope photo now. Todd had a photo of himself looking serious. Are you going to change it back? And I do Zoom calls occasionally with Todd, and every time Todd would pause it, he'd look like this. And for a while I was like, he's so still. Yeah. I was like, he's concentrating.
The whole meeting through, nobody even know you're not paying attention.
Well, and then I win the idiot award, right? Because I was just looking at it going, how does he do that? Like, that must be some meditation technique.
Hey, so anyway, I wanted to share what I'm working on. I'm working on sonic ideas for these UAP. Like we talk about metamaterials. Well, in order to conserve momentum in Earth's atmosphere where most of these sightings take place. The most efficient means of propulsion, even for a slower than light warp drive effect, is to use air as the medium, not vacuum. So using air as the medium, I worked with Chat GPT-4 for a couple of weeks on different ideas for Helmholtz thrusters and other ideas for electromagnetism to see how electric fields and ionization affect sound waves in air. And essentially you can use charge and ionization to change the speed of sound and the density of air. But to generate thrust, it still comes down to the same kind of equations. So what I determined is one of the simplest ways is almost like a vibrating piston. And the thrust equation, write this down, is 4 times the density of the air times the area of the piston, or the area of the diaphragm, in this case, this big circular aluminum thing, and multiplied by the square of the amplitude of vibration and the square of the frequency. And the power is basically the same equation, but it's then the cube of the amplitude and the cube of the frequency, and it's multiplied by another 4. So your velocity is 4 times the amplitude times the frequency. And so your thrust to power ratio is 1 over the velocity. And so you can control your thrust to power ratio by controlling the speed and the amplitude and the frequency of the piston, of the vibrator, the diaphragm. All these things make it much simpler to engineer things like a Tic Tac or a UFO or a graviflyer that we've all seen and wondered how it works. My hypothesis currently for the graviflyer is it's probably operating above normal hearing range, but it's loud, and that's why he's wearing ear protection. That's why he's so far out away from any people, because it's very loud sound. Even if the sound pressures are in 20, 22 kilohertz, the thrust goes up like the square of the frequency. So I built this, if you can see it. It's a piezo transducer, 22 kilohertz piezo transducer. It's dome shaped to reflect the air downward and out. It breathes air in through the sides and reflects it downward. And then this will vibrate like a piston underneath to generate an air cushion that would support its own weight. Theoretically, a device this size, given enough power and mechanics to make it work, could generate over 800 newtons of thrust. So this is where my thoughts have been going for these UAPs and how they move so quickly, and how their propulsion systems may work. Consider like a Tic Tac metamaterial that doesn't, where the whole hull is made of like piezo transducers and vibrating panels that can allow you to move massive amounts of air underneath it or around it or behind it to push it. At the size of this thing, it would have enormous amounts of thrust, and by making the pistons move at relatively lower frequencies with higher amplitudes, you can keep the velocity down and make the power requirements low. So as Jack Sarfati has said about low power warp drive, this is about as low as it can get. But the idea there is you need to make the speed of light lower by controlling his S matrix, or the permeability and permittivity matrices of the vacuum. And by controlling those matrices, you can lower the speed of light and thereby reduce the power required for making a warp drive. anyway, open for discussion. I just thought I'd share with you what I'm working on. I'm going to hang this thing from some bungee cords, and I got the transducer power. Got to fix it. It broke. Transducers here. I'm going to hang this thing from some bungee cords and wear some earphones and turn it on in a couple days. We'll see.
No, that's awesome. Todd, thank you so much. So let me see. I mean, what Todd is talking about here is everybody has their mics and their cameras off. Uh-oh, not everybody.
Well, I mean, I guess I could say something. You know, this whole group, especially All Propulsion as a group, where like entirely what we're about is finding solutions for anti-gravity and even applying it and trying to create it. And the thing is, like, one thing that I really try to put into some of my work or into some of my analytics, I'm not a philosopher. I did study philosophy, but I'm not trying to advertise myself as a philosopher. But the thing is about these UAPs that we're seeing, and a lot of the videos that's already gone public shows that, or at least some of them, to some people, some of them sort of imply or suggest that the material, hence the esoteric study of metallurgy in like Sandia Labs or other places like that, like the existence of those departments, the material that these things are made of aren't necessarily materials that we can even fathom of creating. I'm not saying that's a full limitation to being able to create fully anti-gravitational machines and crafts. I do believe as humans we can definitely do that, especially so in our lifetimes. I'm just saying it's hard for me to hear when us humans are referencing to these crafts and trying to imitate the way they travel through space-time, when the way they perceive and live in space-time in our reality is completely different than how we can ever be as human beings. I'm just saying, you know, that sounds a little crazy, but you know, we're working with aluminum, where some of us are working with, what was it, bismuth composite. No, these things can shapeshift mid-air. Sometimes they can completely disappear, right?
Videos and hearsay, so
yeah, and no, and I like the projects because I think that is still an evolution for man. I think we will get there. It's not gonna...
Well,
I have a little different outlook about anti-gravity because I have an engineering model of quantum gravity that matches general relativity, and essentially it's just a reinterpretation of general relativity and what it means that's compatible with quantum mechanics.
Right.
Same result, but from quantum mechanics, not from general relativity. And the whole idea of curved space-time goes away. It's an interpretation. It's not a real thing. The real thing is the quantum mechanics. The real thing is the right-hand side of Einstein's equation, the T mu nu. That is quantum mechanics and everything we know about physics. And that describes how the pressure and densities affect our rulers and clocks, which we use to measure space-time. So the left-hand side of Einstein's equations is not the curvature of space-time. It is the effect on our rulers and clocks that we use to measure it.
Right.
And I want to make that clearer, that the whole concept of space and time being a manifold or a thing is an interpretation. I keep wanting to say nonsense, but it's an interpretation. And the alternative interpretation is that rulers and clocks and all matter that we use to measure it is interfering with each other at the quantum scale. And that interference causes damping of the quantum harmonic oscillators of the things it's made of. And that damping effect causes it to lose energy and fall toward the source of the damping. And that's what gravity is. And it's compatible with quantum mechanics. It's compatible with general relativity. It falls out of the equations like rain. And once you understand this principle, warp drive becomes, how do I control atoms and nuclei and quarks to make them less damped, to control the damping, and how to move the molecules and the atoms in the ship forward or up, or whichever way you want to go, by affecting the atoms in the ship, not the space-time around it.
I get it. It's sort of respective of abstract mathematics in a way. To be completely honest with you, quantum is really a form of abstract philosophy and abstract mathematics. And I think we're really coming to understand that finally as a human species, which I'm really happy about, because we're not finally in our generation. I'm so lucky to be in this generation. We're exploring science in an abstract way, which is what Plato really wanted to do. But we branched off of that when institutionalism became a thing. That's a philosophy written by Brouwer back in 1960s or something like that. But anyway, when science became a thing where it required empirical senses in order for things to be scientifically provable, well, quantum mechanics and quantum physics and science and all of that stuff is really starting to branch out into the more abstract, the way of things. And it seems like that's what sort of your project is.
I'm trying to bring it back to practicality. Is everything in my model is verifiable and measurable. I don't have any abstract.
Well,
a space-time manifold is an abstract.
I got a question for you. Do you think space-time is virtual or real?
Virtual. Yeah. I don't think space-time. I think of space-time as space is what I measure with the ruler, and time is what I measure with the clock. And my rulers and clocks change from place to place.
So would your ruler? So space-time would be what would account for the fact that the time is faster in space than it is here on Earth? Then
damping. The damping from the interference with the clocks from the quantum fields of all the atoms and matter that make up the Earth and everything on it interfere with the clock, causing it to damping the quantum harmonic oscillators that it's made of, which then makes it run slow.
So you when I think of damping, I think of like a spring.
Yep.
Going up and down, and you put something to slow it down till it stops. That's what I mean by damping.
It stops at the event horizon of a black hole. That's what the damping becomes.
And when you say in a black hole, is a black hole one event horizon or two?
I couldn't hear you. There's some other place.
Yeah, sorry.
Hold on. Let me ask that again. Would there be one or a couple of event horizons or more?
No, just one. Assuming it's symmetrical.
Would there be an outer event horizon where it wouldn't apply anymore?
No, it's just that everything up until the event horizon is underdamped. So the Earth, gravity on the Earth is an underdamped field. At the event horizon of a black hole is critical damping. Below the event horizon is overdamping. And it that's what falls out of the equations. And so it's just like
so it's an equation. It's not a measurement that you're basing that on. So, for example,
it's the measurements that we have for
like a signal
for the Schwarzschild solution. I derived the Schwarzschild solution from this.
Okay, well,
the same solution you get a black hole for.
What I'm asking about is basically in measure when you have a measurement, you have a signal, and then you have this thing called a noise floor.
Yeah.
Okay. So and so the signal, there's an upper limit to what the signal goes. And then if you go over this limit, then you get what's called saturation.
Yeah.
Okay. When you're under the limit, though, you get the noise floor. So like the data at the noise, below the noise floor is just basically noise, right?
Yeah, that's the 0 point field.
So So that's why I'm asking if there's more than one event horizon.
Oh,
Is there a
well,
signal to
I mean,
noise?
yeah, there's going to be an uncertainty as to exactly where it is. I mean, you're not going to define it down to the, femtometer.
Gotcha. So now my other question is, have you ever heard of the phrase space-time substantialism?
No.
So, and basically what that is there's a manifold of events in space-time that's independent from the matter within it. The other term they've used for it is offset spatial divergence. Have you ever heard of that?
Mm-hmm.
So basically, you think the Earth, we're sitting on Earth, and the Earth is rotating around 1,000 miles an hour, and then the Earth is rotating around the sun, and then the sun is rotating around the galaxy, and the galaxy is moving in a galactic cluster in our universe somewhere. Everything in the universe is moving with respect to everything else.
Yeah.
Okay. So essentially, if you're moving in a reference frame where you're going really, really fast, okay, but you're below the speed of light, to someone that's sitting in as an observer in a different reference frame that's not accelerating, for example, that the observer outside the reference frame, the moving reference frame, would appear to exceed the speed of light. But from the person who's
an accelerated reference frame, in an accelerated reference frame, that's fine.
Reference frame is slower than the speed of light.
Yeah.
Correct?
Yeah.
So that still works, right?
Yeah, but it's accelerating, so that's the perception you'll get.
So what this is saying is all that what space substantialism basically says is we have the superposition of the past and the future in the here and now. The past and the future are virtual, but what's going on right now is real.
Yeah. I don't believe in the block universe. I don't have a block universe in my model. Time is not, it's not a fourth dimension like you can slice into it. You have the 3 dimensions of space filled with matter, and matter moves, and that gives us clocks, and that's what time is. So.
And then my last question is, do you think the speed of gravity is the speed of light?
Yeah. It has to be. It's mediated by photons.
Okay. Well, photons have no mass. So how can
they do inside inside the nucleus, and then we call them something else. We call them gluons.
Wait, what's that smile? There's a smile there. He said gluons. I saw a smile. You know what? I should get Mark Fiorentino should jump in really quick too, because he has his hand up.
Mark, you should just jump in.
Todd, I like to get this straight. So you're saying that space is not a real thing. It doesn't exist in an objective reality. It's not physical. Is that correct?
It's an empty stage in which we play.
It does not exist.
Shakespeare put it.
Exist.
The space, the emptiness.
Space. Is it a physical, real thing or not? Is it an abstract, virtual thing, or is it something physical and real? Yes or no?
It's an empty box. Is emptiness real? Is if something doesn't exist, it's an empty box filled with fields. The fields exist, but does the space the fields are in, is that something or is that nothing?
If you define it,
this is Plato, I think, isn't it?
If you define it as a box, then it's something. Then you have to ask what the box is.
No, there's matter, and there's where matter is. And there's fields, and there's where the fields are. But the fields are what is real, and you have to measure all your coordinates of space by what is in the fields, not by the space. There's nothing to measure from. If you didn't have any matter in space, then you have no reference point for size or scale. So there is no scale. Space doesn't exist if there is no matter with which
Okay,
to
I
use
got
to
you,
measure.
right? Good. Space doesn't exist. If
You
that's
need matter to measure it. You wouldn't know if it existed. Let me put it
well,
that way.
if
What
that's true,
about the Planck length though? What about the
Nonsense.
but isn't that a
okay.
fundamental property of space itself?
No, it's just the trick of mathematics.
You
Together certain constants, and that's what you get length.
I'm
you
with
had
you,
said
Doug.
that space does not exist. If
Also
if
the-
distance equals rate times time, how come it takes about 8 minutes and 19 seconds for light to get from the sun to the earth? If
Because the
space
field is
isn't
that
real,
big.
if it doesn't exist, how does that time interval occur?
The
It
field
has
that's
to
traveling, the
exist.
electromagnetic field that's traveling through exists. You're trying to deny that and say, oh, well, it's space that's moving. No, space
But
is
the field traveling through space means that it's traveling through something.
it's traveling through the
Empty.
electromagnetic
If it's
field.
empty and does not exist, it's not there. Therefore, any points between A and B have no distance.
So
You're twisting my words.
Well,
My
hold on,
words
hold
are not that
on, guys,
it's
hold
not
on,
there.
hold on. Let
My
me see.
words are that you don't know.
I think you guys are kind of saying the same thing. I think it's just different terminology. But so Todd, kind of what you're saying is, and I know you hate this word, you're kind of saying that the fields are the manifolds.
Yeah.
So instead of
real.
yes, so instead of space as one thing, space would be, you could almost like slice it up into like electromagnetic and maybe strong force, and
they're all fields.
Yeah.
The frequency.
But you can represent the field as a wave particle.
Wait, sorry, Michael was jumping in. Michael knows something. He has pyramids.
Yes, sir. Okay, you have a bandwidth of frequencies. Space is in there somewhere. You got gigahertz, megahertz, low frequency, high frequency, light frequency, sound frequency, space frequency.
Yeah. So so then that would be the what Mark was saying about the time it takes for light to get to the Earth. If I understand what Todd is saying correctly, and that's almost like, and again, I know this is another word he hates, string theory. But like, see, look at that smile. Yeah, but I think the idea behind string and brain theory was to basically break up space into these different manifolds, and then we're saying, okay, electromagnetic, and then the speed of light is like the propagation speed through the electromagnetic field, right? But then the thing that I liked about that was, okay, with Einstein, he said, okay, this is what it is, and it takes an exponential curve to get there, and therefore you can never exceed it because that exponential curve goes infinite in terms of energy. But if that's the case, if it's just the propagation speed, maybe you can exceed it. Maybe that's the natural speed that it propagates at, but there's lots of ways to go faster.
Yeah, but getting back to what Michael Boyd was saying about, you got all the Earth's moving and the sun is moving and the galaxy's moving and everything's moving. And based on some calculations that Rick Storty did, if we eliminated the gravitational field from all the matter in our galaxy, it wouldn't even increase the speed of light 1%. Which is kind of disappointing, which means you need to change it by a hell of a lot more than what we are, capable of to get speeds like 200 times the speed of light or something like that. It's like, even if I remove the entire galaxy, I couldn't raise the speed of light by more than 1%. And that's pretty bad, just because the area that fills the space where our galaxy is, I should say the fields that fill the space where our galaxy is, like Mach's principle from all the rest of the matter in the universe, that's what sets the speed of light here. And compared to all the matter in the rest of the universe, our galaxy is negligible.
Yeah. But I think what you're saying is, and this goes back to this whole idea of like the map is not the territory, right? And it's ultimately it's all how, it's all how we define things, but it, in a weird way, like I get the feeling that modern it seems like everyone is converging on different types of etheric models, right? Even though we're not allowed to use that word, so just forget that I said that. But if
Just call it fields.
You mean
Just
like
call it
ether?
fields.
yeah,
Are you-
yeah. Well, no, don't. Yes, it is the
Call
name
it
that
fields.
it's like Voldemort. Do not speak his name.
Either this or either that.
Yeah, but
It's the idea that light is itself creating this matrix. So this idea of what is space-time itself, and the space-time itself could be the mapping, the map of light between particles, and it's constantly reevaluating itself through,
Well, the point that I'm trying to make here is that if space is really nothing and only the particles are something, how can it take a particle that's something a certain time interval to travel from point A to point B if the thing between point A and B is equal to nothing? That means it's equal to 0. So that means its distance, no matter how far apart, would always be physically 0. Therefore, it would be instantaneous travel from any
You're making an
point.
assumption.
well,
You're
and
making an assumption.
yeah, I've approached Mark. I've approached the same concern, right? And I'm the first to admit that I'm ignorant, but I've approached the same concern from the like momentum, right? Okay, how is momentum transferred? How do you even know that momentum or kinetic energy exists without some third reference frame? And then that reference frame. Now, I think what Todd is saying is that third reference frame is the fields. What you're saying is that it's the background of time space. And then I think in traditional relativity theory, I mean, they have like the Lorentz, Lorentz symmetries and stuff like that. But I mean, this idea of there has to be something there to compare it against. Otherwise, you can't have.
What if empty space is a form of matter?
Well, and that's your quantum
Very good
foam,
answer,
right?
Michael.
That's your quantum foam. And maybe quantum foam explains all of this, the virtual particles that come and go.
Well, it explains.
Mark is assuming that the space from point A to point B is empty. It's an assumption.
What if matter is a
make
form
that
of
assumption?
So the empty space has a structure to it, just like the matter space.
No,
That's
it
what I
doesn't.
found. Is
There's
when
nothing
I-
there, Michael.
And
There's
made
nothing
a
there.
little nano pit and ran it under the MR sensor.
Yeah, but you're
and
misinterpreting.
measured it physically with a piezoelectric crystal. It moved, it pushed it, and it produced a push force that
You
I
never
could
had a
measure.
space with nothing in it.
Well, okay, but what, Todd?
But
how
that was
would this?
obviously that
Might I suggest something?
of nano
Yeah,
pit.
oh
it
yeah,
wasn't empty. It had air in it. Okay.
Can I suggest something?
Let Don, Mr. Black, jump in, sir.
Perhaps it is that matter is space. That is, you take a bunch of space and clump it up, and you have what I characterize as a dimple. Well, being egocentric, I characterize it as Don's dimple. But consider that all there is space-time. You have to look up, go to the Stanford Philosophy Encyclopedia and look up space-time supersubstantialism. Basically, it's the idea there's nothing exists except space-time. And I have some theories as to where that came from, how that is emergent. But perhaps all of matter is emergent from space-time in the sense that all of matter is clumps of space-time. And the fact that time slows down around matter, we've got more space-time there, so it takes longer for time to propagate, and hence the speed of light slows down around matter. As you witness that when the speed of light comes to the event horizon of a black hole, it stops. Time goes to 0. So that's a pretty radical and a provable demonstration that gravity and slower time are the same event.
The thing that I like about
I like what you're saying.
I like that. The thing that I like about that idea is you can create particles, right? If you put enough energy into a small area, it pops a particle out. That's how, you know, that's matter and antimatter. So
energy, time, energy, mass, no different. Energy
Just
mass
seems
is
to
just
me that
dense
it's going backwards, because trying to get matter from space-time when we already have the most, you know, accurate models in the standard model of particle physics, and we
Well,
should
I have not examined the
time out of
mathematics.
that, not the other way around.
I've examined the mathematics a little bit, but I have not created any proper falsifiability to actually propose this as a theory. I just think it's a fun idea to play with. And there are all sorts of implications that when you start knocking this idea around while you're falling asleep at night, that you can see some very interesting implications, like the whole
But Weil and Einstein and many others have been working
Science is about we come up with theories, but they have to be testable. So we have to come up with your theory must predict something that we can test.
I said I don't have proper falsifiability for it. I'm just sitting in here and people are knocking around these ideas, and I thought I'd just throw out one of my.
No, I think that's a great hypothesis. You know, so if I could,
and I appreciate the criticism, by the way. So have at it.
Thank you. Thank you.
I saw this is brain theory. It was an interview with Lisa Randall and I think Brian Greene. They were talking about string brain theory. And one of the they just put this forward as a pie in the sky hypothesis, but they had a visualization of they had a gravitational membrane or field, right? And then they had an electromagnetic membrane or field. And they said, what if the Big Bang was when these two membranes, which were out there and time was below both of them, what if they collided and the Big Bang was where they collided? It was the overlap, right? And you know, and again, it goes back to this whole idea of something coming out of nothing. But this is just me. I don't think that's mutually exclusive from what Todd is saying. I think what Todd is saying is these are brains or fields, which is basically what the membrane is. And that's what space is composed of, right? As opposed to being.
I have a suggestion. I've been studying time and multiple dimensions for about 20 years, since I got my PhD. Since before I got my PhD, because I did my PhD on multiple dimensions. And it's quite interesting, depending on the size of the bulk, how other dimensions interact. Like, what if time were a one-dimensional hyperbolic line, if you will, nonlinear, and you have this 3 space. Now, what happens if you have a 4 or 5 space and the 1 space intersects the 3 space? What happens? There's some interesting ideas. Where they intersect, it's a point. Depending on the size of the bulk, the shape of the intersection changes. So there's like all sorts of other dimensionality that can occur as from this intersection inside the bulk. There's also some very interesting papers. I think Lisa Randall wrote one of them about why if you have 10 or 12 or 20 dimensions, 4 have to emerge as stable. I mean, 4-dimensional space has to emerge as stable. Some of that stuff is fairly complex. I'm still trying to slog through it myself. But if this arrow of time intersected this 3 space, there would be an immediate explosion of time of somehow, some magical way, these 4 dimensions interact. And perhaps this would explain both the Big Bang. This would explain mass and energy, since mass and energy is a function of time. That is, if you have a clump of time, then you have mass energy. So here's this one point where this one-dimensional hyperbolic line intersects 3 space, which could be Euclidean. And immediately from that point out, the interaction causes this, well, let's call it an explosion or inflation or cosmological inflation. And if the time axis is nonlinear, that is hyperbolic, then this intersection might release continuous energy and continuous expansion in the universe. Again,
So
this is like a dream.
Forever universe, then?
I haven't really measured the length of the time axis, but as soon as I do, I'll let you know.
John, when you think about using quasi-crystals as Quasi-crystals are
Green
three-dimensional
is-
objects which can have hyperdimensional symmetries or structure to them. What do you think about the ideas that and they also can be used as metamaterials? They can bend fiber optic signals at 90-degree angles without losing signal quality. There's a Princeton study done by Eric Quinones a few years back on that. People can look up quasi-crystals. As you mentioned, explosions. They are also formed in nuclear explosions. They're found in pieces of trinitite. It's what do you think about the idea of using, potentially, because I think in terms of engineerability of how we're going to actually build this thing, and one of the things that I've come across was this idea of quasi crystals, and I was wondering what you thought about that.
I have already said more than I know. If you're talking to me,
yeah,
I agree.
Sorry.
I agree.
So I'm curious about this, the reports that have come out around the James Webb Telescope, where it basically went back to within 100 million years of the so-called Big Bang, and that it found that unexpectedly that galaxies were the same size as they are now, which would seem to disprove the fact that there was a denser space-time in the past, when the universe was formed in this Big Bang, so-called Big Bang. Why would stuff be the same size? And does that suggest the idea of a hyperbolic universe, where the universe is expanding, but the stuff within it is still the same size?
Yeah. Oh, I should, so Tammy just dropped a link. I've been ignoring the chat. Tammy, did you want to talk about the Springer link that you dropped in? And then I should go to Therese and Mark also, and at least ask if they want to talk. Tammy, did you want to? Oh, there we go.
Can you hear me now?
Yeah, now I can hear you. Yeah, so
Hey,
you
how's
were
it
saying
going?
the hyperbola would explode into a torus.
Yeah, it's a toroidal shape. That's just a theory. Yeah, I was looking at the gauge theory approach to that in regards to how that might intersect with M theory and string theory. So what was interesting to me when they talked about, I'm sorry, I forget who was just speaking on this subject matter, but I had read previously about the toroidal forms and how that might explain that. So I just dropped that in the chat because it's not a paper I really was familiar with. I just wanted to give a reference a little bit. Not something I'm prepared to speak about, really. I just wanted to mention that. So if anyone else has anything to say about it, though, maybe I could just introduce the topic here. Thank you.
Oh, awesome. Well, thank you. Thank you for dropping that in. And then I should also ask, so let me see, Therese Pope, and let me go to Therese because I just saw him pop up a moment ago. Therese, are you still with us? Okay, looks like he's still there. Let's see if he wants to jump in really quick. He was saying if you could put something in space, then the space has to be there before the matter. It's like chicken or egg. Yeah, what comes first, space or matter? Gravity or matter? Gravity, of course.
Can you hear me?
Yeah, there we go.
I was
yeah.
suggesting that.
Oh, well, if it's okay, let Therese go because he took him a
sorry.
moment. Oh no, that's okay, Don.
No, that's fine. It was just a part of the conversation they had earlier. I mean, as far as my understanding goes, as far as space and time, I mean, I'm understanding that as far as like the matter, I mean, the space has to come before matter. I mean, and then what creates that is basically the density of the space-time curvature basically creates the density, and then that creates gravity, and then the gravity concentration of the gravity is is basically what makes the matter and basically the everything else.
Okay, I think I think what Don Black was hypothesizing is very similar to what you're saying.
Yeah.
Just the opposite.
Oh, okay.
So something different. Okay. You can go ahead.
Okay, well, I was hypothesizing that, well, one thing I learned from looking at some of the masters is that you don't have to figure everything out all at once. You can just grab, like, this started after the universe started, and then this is what's going on now. I don't have to explain everything that, you know, how God created the universe or the spaghetti monster did or whatever. So as far as time and space are concerned, I'm hypothesizing that we have a Hilbert space of, or we have an infinite number of dimensions. The bulk is infinite. And in this bulk, there are many brains of different dimensions. And where the universe that we are familiar came from is where a one-dimensional hyperbolic time dimension, or what makes that dimension time-like, is that it's hyperbolic. So that a hyperbolic nonlinear dimension intersected with a three-space Euclidean dimension. And the intersection of those two dimensions created the space-time energy matter universe that we see around us. And there's a couple of, if you start exploring extra dimensions, whole new worlds, no pun intended, whole new worlds open up for you, and how you can explore, well, like Michio Kaku said, all of the physical laws we see around us today are the result of symmetries of higher dimensions. I took that to heart and started exploring higher dimensions. And it's, I plan to do a course on them. My name is Don V. Black, as you can see there. My website's donvblack.com, so you can go there and, or just email to me at donvblack@gmail.com and get on one of my mail lists, and I'll make this available to you guys. I like this group. I want to hang here for a while.
So would space in this model of yours, would space be the hyperbolic part?
No, time is hyperbolic. IPT, if you multiply the time axis, the speed of light is a scale factor between the time axis and the space axis. That's the best way to describe what that is. And, you know, mathematically it makes sense. And for some peculiar reason, the time axis happened to be a hyperbolic one, luckily, and the three space axes were Euclidean, and for some reason they intersected. If they were in a, all right, I use analogies like we have a 2D plane and we have a 1D line, okay, and it's in 3 space. So envision, if you will, a 2D plane and a 1D line. There is only one possible orientation where that 1D line in 3 space would not intersect that 2D plane. You know, and it's impossible that it could randomly end up in that. I mean, the probability of it ending up parallel to the plane is 0, you know, or 0.00000, you know, however far you want to carry it out, it's 0. It couldn't do that. There would have to be some angle. We're assuming both the plane and the line are infinite. Okay, in respect to your question about whether or not time is infinite, yes, it is, because the intersection had to occur. And if both the plane and the hyperbolic axis were infinite, they would have to intersect. So they intersected. They could do nothing else. And when that happened, then there was some kind of peculiarity happened, some magic, which I have not yet explored in detail, between the intersection of a hyperbolic line and a Euclidean 3 space. When do you guys figure that out? You're smart. But I suspect that this led to the expansion of the universe, inflation and the continual expansion. And also, we do know that it's a fact that there's a relationship between gravity and time, between mass and time, between energy and time. So perhaps this intersection injected mass and energy into this Euclidean 3 space. See, it's got interesting. I mean, it carries over into when you start talking about spin. Spin could be described as the rotation of a three-dimensional object in 4 space. If you look at the arithmetic of the intersection of multiple dimensions is really trivial. You take the codimension, and the difference between the codimensions of the 2 dimensionalities is the size of the intersection. Okay, like your plane and line in 3 space, they have to intersect in a point. That's the only way it can happen. They intersect in a point. I mean, unless you can happen to, again, something infinitely improbable, if you could actually align the line with the plane, you know, put it down in the plane so it was perfectly aligned and in the plane, which again, the probability of that is 0. The same way of the thing being parallel to the plane in any way. So it's got to intersect, it's got to penetrate. I call it the Big Berth. I could hold forth on this for hours. And I, out of deference and respect for you gentlemen, I won't, and ladies.
That's great. Well, that was great. I enjoyed, and I think we're on the same page.
Yeah.
Yeah.
Well, I don't.
All the things
again,
you guys have been saying have been like orbiting this idea. So that's what gave me the courage to say it. I've been thinking about it, but you know, I got like 100 pages of notes, but nothing that I've would commit to a paper at this point.
well, write them down. Write them down to a paper. Get somebody to help you finish it off. You know, and then.
Yeah, I'll review it.
Who was that? Who was that? I didn't see who was talking.
This is Mike Boyd.
Oh, Mike. Okay.
Yeah, so I posted my paper that I'm trying to get reviewers on, so please download and take a look at it. It's got my email there
You
too.
familiar with Paul Wesson and his space-time matter theory?
I've heard that name before.
Go read it. Do it before you publish.
Okay, will do.
Unfortunately, he died in the last couple of years. That's a great loss, but guy was brilliant, and he's, well, space-time matter. That says it.
Wesson, W-E-S-S-O-N?
Right, Paul Wesson.
And what was the title of the paper?
Space-time matter.
Space-time matter. Okay, I will. Thank you.
Sure. I'll be happy to talk to you about that too.
Yeah, I would say go for it. Go for it.
You know,
things have gotten kind of quiet. Nobody has their hand up, so it's like
this stuff is really deep. So you know, like he's got like 3 books, and you just go through them over and over again, and you know, find new stuff every time. So it'd be useful to talk to someone else who had actually read them. I'm looking for your email address, Michael.
Oh, and now Mark has his hand up. So Mark, if you want to jump in,
I'll post again and with the paper again, and then
I got the paper.
Thanks.
I think it is exciting though, this idea of particles emerging from space itself. I like that. I mean, and it squares with quantum mechanics, right? So.
Well, I really think that particles are consubstantial with space. They are made from space. They are the same as space. They are just geometric configurations of that space.
Yeah, I think that's what, yeah.
And so really, that's the underlying medium, and it's obviously got to be a quasi-elastic solid. And there's evidence for that. There's lots of evidence for that. And I'll give you some. First of all, what is a transverse wave? How transverse waves, according to Einstein, mostly occur in a solid. Also, space has measurable properties like permittivity and permeability. If the thing was made of nothing and did not exist, it wouldn't have measurable properties of permittivity and permeability. It takes light time to traverse across it. Therefore, there must be something there to traverse across. Otherwise, if there was nothing there, it would take zero time for light to get from one spot to another. There's a lot of evidence that says space has got to be something. Now all we got to do is figure out exactly what it is.
Nothing.
And my vote is for the Lorentz model, which is quasi-elastic solid.
It's a manifestation of nothing. If the universe came from nothing, and it's still all conservation laws are in place and have been since the beginning of time, then everything's relative and everything's just a disentangled sort of a hyperdimensional mess that somehow from the Goldilocks hypothesis settled on this universe that we all inhabit and share.
Okay, so we can become the nothing society. People ask what we do. We study nothing.
Yeah, we study nothing.
We're a glitch in the matrix.
Nothing's the same everywhere.
I put my email again up on the chat.
Okay, thanks.
There's a couple great books about nothing. One by author Casey Cole. Check out. It's a whole book about this and the philosophy of this, and really interesting stuff.
Yeah, we're doing pretty good tonight, guys. We're doing pretty good. It started off a little slow. Everybody was really quiet, which almost like terrifies me. But
what is space is an oscillation?
So sorry, Mike, I couldn't hear you.
What is space is an oscillation? Oscillating wave, or it's an oscillation, like a frequency.
Mike, seeing you with your hand on the pyramid, you look like Moses. I swear to God, I thought that was Moses for a moment. I was like, oh, I'm in such deep trouble.
I mean, everything is oscillating.
Can he repeat what he's saying? I can't hear him.
Mike, do you think you could move closer to your pickup, to your microphone?
Can you hear me? Hello?
Yeah, I can hear you. It's just you're way away from your mic.
Everything is oscillating. There's nothing you can find that's not have an oscillating frequency. There's nothing that exists, including time.
Nothing exists. You got it.
Negative temperatures?
No, so it sounds like what he's basically saying that everything's basically a waveform. Basically.
Even a standing wave is oscillating in place. It's just not moving, but it's oscillating in place.
Yeah, they proved that with the absolute zero experiments, right? Where they found negative temperatures. And they're like, wait a minute, there's like a whole bunch of more waves or freedom, I guess degrees of freedom that we don't even know about, that we of matter.
What if space is that standing wave?
Well, I'd like to add to that. Einstein said that nothing happens unless something moves. So you're making
That's exactly right.
That's true.
Tim, can I add something?
Yeah, go for it.
Yeah, I've written a book called Cosmological Balanced Universe, where I talk about everything you're mentioning here in this forum. Space is derived from nothing, and it is a balance of zero mass, but it oscillates between positive mass and negative mass in order to achieve zero mass. And from space itself, it is a self-contained entity. In other words, it's a huge bubble, finite size. Within that bubble, matter is derived out of space itself, the materials of space, and also antimatter is derived from that. And both of them, matter has positive mass, the true antimatter has negative mass. And the universe is divided in such a way that the two cannot collide, the antimatter and the positive mass and the negative mass, because of Newton's laws. And if you look at adding a negative to a mass in Newton's equation, it repels, does not attract. And I described all of that in my book, and I shared with the audience here, the peers here in this forum. my paper on quantum gravity, and I also shared the link to my cosmological balance universe if you're interested in looking at it. But I'm looking for peer review on my quantum gravity paper. I call it quantum graviton.
Thank you, Mike. So in your book that, or in your model, what you're looking at, where would the negative mass be?
The negative mass is pictured on the W map or the Planck 2017 images. If you look at those images, they have bubbles, spherical looking pieces in the whole scheme. Those are the halos of anti-gravity galaxies. In other words, spewed out of the center of the galaxy is matter that comes out and is emitted at the halo of the anti-gravity, antimatter galaxy.
Okay,
the same is happening in our galaxy. Spewed out of our black hole is dark matter, which comes out at the edge of our own galaxies, the ordinary matter galaxies. And that's a balance. That's why I call it cosmological balance universe. And I call it unified theory because in that book, I also present my quantum gravity paper. And I shared that with the audience here.
Yeah, I've heard ideas like that before then. I think I understand what you're saying. And then we would only see the positive stuff because that clumps together and the negative stuff would be just a long ways away.
Correct. And so the best we can do in anti-gravity engines is to just nullify gravity or nullify mass in order to ride at the speed of light. That's the best we can do with our instruments. And I'm trying to go through some ideas on how to produce anti-gravity with what I have in my theory. However, whatever materials I use, I can't cancel the mass in the material to achieve anti-gravity totally. If I were able to do that, I can jump out of the Earth at twice the speed of light or square the speed of light.
Okay.
But I haven't figured that one out yet, so I'm still working on it.
Let me leave you with this thought. We are all wrong, every one of us. But we could also all be right, because the universe is infinite. If there's an infinite number of if there's a Hilbert space and an infinite number of dimensions, then anything you can imagine exists somewhere right now. And except for in the case of proper falsifiability, probably all of our theories overlap in some way. That is very interesting.
Well, so then Dawn, how would you, and I guess this is probably the big change for this year, but it looks like, I mean, again, everything I've seen says that UAP are real and they're vehicles and they're using, I mean, it could be warp drive, could be some kind of gravity control, something along those lines. So if that's the case, it's already been built, right? And I think that's what Jack Sarfati has been saying repeatedly is, you know, and he's using that to justify his model. And I don't have any major complaints about that. I think everyone's probably going to, but it's like, okay, I guess what I'm wondering is, what are your thoughts on that? You know, and I don't know if there are any at this point, right? It's all of this is so out there, but.
I think that using Occam's razor, it's much more probable that I could build those spacecraft. And the way I do it is I take a whole bunch of drones and use holography and project radar waves and images to the enemy's sensors. So I think that's the most likely scenario, is that they're coming from China. It's projections of holographic images over the horizon using some kind of technology that we're not familiar with, which makes coming from China is a lot easier than coming from Arcturus or Andromeda. And you have to, proper falsifiability is probably coming from the planet. And I know I could do that myself. I mean, you know, there's real simple, we know enough about electromagnetism that we could create the proper interference patterns if we put enough money into it.
Yeah, and Don, actually, I'm looking up, here we go, Eric Hazeltine. I did an interview with Eric Hazeltine on Havana syndrome. And from what I remember, he's not a physicist, but he was maintaining something similar. In his case, he was saying that it was a plasma effect. I think he was talking about lasers and plasmas, similar to what you're saying, holography. Well, let me see. Oh, Mark has his hand up. Mark, do you want to go for it?
Yeah, speaking of anti-gravity, what does everybody think of the Biefeld-Brown effect? Anybody?
That like having two grounds?
No, using a dipole or electrostatic field to generate an anti-gravity field.
Have we done the vacuum chamber effect, vacuum chamber tests on this?
I think Ivo is doing a mission in October for that, but I don't think anyone has done true. Every time a vacuum chamber has been done, there have always been flaws in it, right? And so
Ivo is knocking off my technology.
Well,
and they're gonna wish they hadn't.
I believe they're doing the vacuum chamber test just to isolate it from the ionic wind theory. Is that correct?
Yeah, the prevailing theory, I mean, Martin Tajmir from the ESA said Europe's NASA has basically, declared that it is ion wind 100%, and prove us wrong.
I didn't realize we had such an interest with Ivo. Do we have
I don't trust them
in this group? Okay. We don't want them. Okay.
Well, no, Ivo is actually, I reached out and I talked to one of their staff members, and he said that they're open to presenting, but they want to see what their results are. So the thing to keep in mind is they're very sensitive. They've got their, they have their business plans and stuff like that. So they want to be careful about what statements they make and when they make them and all of that. So.
Thanks.
Yes. Well, did you notice that they pulled out of their launch?
Well, what I heard was that it got postponed.
Yes, they pulled out of their launch. They're going to have a very bad month. They just don't know it yet.
Well, you guys had talked about launching something too, right, Drew?
Yes, we are. We've decided that we're going to go ahead and probably try to pull off a full lunar hover. So we're going to, do the same thing, ride share to get into low Earth orbit, and then we'll putter on out to the moon, and then do a kind of a lunar hover and hover around and whatever. Since we don't ever run out of fuel, we don't ever have to worry about running out of fuel. So we have big dreams. There's more slated toward a year from pretty much the end, probably 18 months from now. It's going to be great.
Yeah, no, it's exciting. It's exciting. Let me see. And then Mike was saying he was proposing an idea about using centrifugal force for lift. Okay. Mike?
Yes, sir.
Yeah. You were talking about centrifugal force?
Yeah. Solid state centrifugal force.
Okay.
Using an iron ring and electromagnetic coils on the ring, pulsed, not simultaneously, but in series around the ring, to create a solid state spinning, maybe not matter, maybe matter, I don't know, it's something spinning in the ring, right? It's electromagnets, no?
Yeah, rotating magnetic field.
I was thinking plasma.
Using an iron ring, one iron ring with a coil or two or three wrapped around it, or let's say 3 coils pulsing in fashion like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and it's the same direction or the other direction. And that's solid state centrifugal force. To some degree it is.
So something, yeah, I understand. And actually I've read about variations on that too, being attempted. So, and actually, let me see, Donnie M is writing, consider Standeo. So there you go.
Yeah, I know Standeo. I never heard him talk about anything like that yet. But he does have amazing things going on.
Is Stan still with us?
Yeah, he's on this channel on YouTube.
Oh, okay.
I don't remember the channel offhand. I think it's his channel, or no, it's not his channel.
I wasn't
but-
sure. I mean, a lot of, unfortunately, a lot of the folks in this community have passed, right? I mean, one of probably the best known is John Searle. He, and that was a while ago, but
He's making these whole house surge protectors that actually work compared to other surge protectors that don't work. Protects the whole house, and that's what he's focused on right now. He thinks that there's going to be he talks a lot about solar pulses, so the sun pulsing, destroying our electronics and stuff.
yeah. Well, let me see who else has stuff. I should get Stephen Greer. You know what? I reached out to Stephen, but it was before the disclosure event. Maybe I'll reach out to him again and see. Sorry, that was
Anybody here do any centrifugal work for like propulsion wise?
I interviewed a fellow many years ago who wanted to do. Was it centrifugal or centripetal force?
They call it centrifugal, centripetal, whatever. It's just spinning.
Yeah, and then there's the rotating gyroscope. I mean, basically we're talking about gyroscopes, right? And so yeah, we've had a few.
Well, yeah, I think that's where it's at, spinning mass or spinning electrons.
I think Mike Gamble has worked with that. Yeah, Danny Cohn is talking about you can use a flywheel to generate lift. So yeah, there have been lots of, for me, I kind of classify that as like inertial propulsion, right? Because you're using mass to generate lift as opposed to field effect stuff. But yeah, there's a whole school of folks building stuff. And then they're like, I guess compared to that is like off-center rotators, right? Which are,
well, similarly, the ion propulsion, like, ionizing a plate of aluminum to a high voltage static field also creates spin vortices, it's the plasma, but the plasma is also spinning, even if it's spinning like that, double toroid. So you can't get away from the spin factor when it comes to most of these lift technologies. Even if you're using high voltage, you're creating a pressure wave that's going to spin most likely like that. It's double toroid, the toroidal spin.
absolutely. Well, let me see. So who else does anyone have questions, thoughts, ideas?
I did have a quick question in regards to the anti-gravity discussion. Has anyone heard of I'm not sure, I've heard about it. I'm not sure if there's been an experiment done yet on basically the same pole electrogravitics, basically like how if you put the same two magnets together, the same pole, they repel each other. So basically, if you were to build something like that inside of a ship or something, basically try to build a ship, basically put some form of electricity to these two opposing forces, that they're going to basically eventually cancel each other out and begin to lift, because they're both opposing each other, and they're going to cancel out the gravity that's around them because they're opposing each other. You kind of understand where I'm going?
Wouldn't that be bucking fields? Bucking.
You got bucking fields. I think so.
Yeah, I believe that's what it's called.
Earth's a group. Did you hear me?
Oh, yeah, we missed you. Sorry.
Am I, do I have the mic?
Yeah. Yep.
Okay, I'd like to comment on the repulsing magnetic field. I had a close friend that was an autistic, and he got really deep into things. And,
I'll be right back.
But you had to interpret him. And before he died, he sort of like, I spent a week with him. And he was really big on this repulsing magnetic field things. And it took about a decade to put it together. And it was after the AI sort of helped me understand this cross-discipline stuff, because there's a lot of concepts that don't translate. For instance, the NMR industry is taken over by medical practitioners, and the physicists sort of like left it alone. And their jargon doesn't equate to physics; it equates to lines on a graph, right, etc. So, repulsion creates a magnetic density. You're like in the middle of the pole. You're on the pole. It's around you. You have a homogeneous field going by. If there's any changes in that, you're changing magnetic density at that spot. So you can get a magnetic density oscillation. This friend of mine, did I say I had a friend? I can't remember how I started, but this friend of mine revealed that he worked on a project which no one here would have ever heard about. And no one was supposed to have gotten off the project and remembered anything about it. But he said they instanced an 8-foot diameter glowing skyrmionic boson on a 1/4 inch lead target in a dielectric center in 30 kilowatts of magnetic noise that never crossed zero. There you have it. And that was pretty weird stuff. But to only add credence to that, he's strange, because I went to travel to get his deathbed experience. His family stood in a circle and told me when he came home and put his mind dump, this autistic mind dump, when he touched the universe in the barn, he had to come back and live with mom and dad. They all went outside because the metal UFO with the barn with a blue beam on it. On the barn, ignited the barn, and they all stood in the yard watching the barn burn, and then the house went with it. Right. So that was the guy that shared this with me. They don't want us to know that you can get a macro quantum resonance. If you want to ask me, one of the ways that you can make macro quantum spookiness that just doesn't behave like our book learning says it should. God bless Newton. Over. Oh, did anybody hear me?
Yeah.
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 Sorry to bring the room to silence there. I was either awfully dumb or awfully profound. Somebody to say something. Okay, going to.
Anyone here ever heard of Ralph? Anyone ever hear the name Ralph Ring? Ralph Ring is the guy who levitated the ping pong ball on Time magazine in the 80s.
Did anyone figure out how he did it?
Yeah. What did he use?
Sound waves, sound.
Okay.
Vibration.
Yeah. That's fine.
I mean, that would make sense.
Okay, and that's what Todd is working with right now. Todd's working with sonic levitation.
We also work with.
Pardon me. On Ion Wind, an earlier comment made. I hosted a guy's website, so I wrote a little bit about it, and then he disappeared when someone bought him out. But he had the, if you remember, Purdue tested a ping pong ball ion thruster. It had ping pong balls over the corona points. And this guy was like Czechoslovakian, and I cannot pull his name. This was like 3-4 web servers ago, 2000. Anyway, so he just disappeared, but his ping pong balls had a corona point inside of them. Both two of them, and you just have a little pivot. So it's not wind, folks. Not with his device. And it was just high voltage corona point over.
Right, you don't need to use sound, you can do it with voltage.
Yeah. Yeah, you can build up a hell of a charge on a ping pong ball and just cool them with traction or cool them repulsion.
Oh yeah, that's a good point. Because it's plastic.
I'm getting real good at figuring out ways the universe can lie to me.
Yeah. And I was going to say, I feel like
it is real easy to get lost in the endpoints of an electrostatic field. You can dump an electrostatic field onto things you wouldn't even think would be able to hold a charge.
Oh
Yeah, you know, and I found also, I mean, again, from working with lifters, way back when, just you get into high voltages and things conduct. I mean, the air, you'll get streamers of ions flying through the air, which is crazy. But
Yeah,
and
air
then
is a
other
metal.
stuff. Yeah, well, and then concrete conducts, at least here in the Pacific Northwest. So
And anything with water in it and on it, it would. And if you can see it, it has water on it, because there's molecular water on everything on this planet. I don't care where it is. I don't care if it's inside the driest vacuum chamber on this planet. There's still molecular water on it. If there's molecular water on it, then a high enough electrostatic field is going to polarize it and it's going to start generating forces. It's really annoying.
I once had a job where I was working at an environmental test lab, where I would take a little straw and stick it in the lid of a part, you know, like a chip, and suck out whatever was in there and measure that it had less than 1% water vapor content. And that was a requirement for military parts. You couldn't have over a certain percentage of water vapor content in the container. So it's actually a mil spec.
Yeah, it's real dangerous to drop the humidity below about 50% in a package. I'm a professional precision clean engineer. It's real dangerous. You start getting electrostatic buildups. You can, especially with today's integrated stuff, you can kill chips just with the packaging.
You're saying it's 50%, excuse me.
And it would be if you want whatever's in there to survive. If it's electronic component of any form whatsoever, you want to keep the relative humidity inside that package to about 50%. If it drops below that, that's just suicide for what's inside that package. Most things are poly. You get polypropylene, polyethylene as your packaging material. It's super electrostatic.
So it would basically fry the part. Is that what you're saying?
Yeah, you can build up 100,000 volts on a part just by people do silly things. They pull vacuum, they put their electronic widgets in a bag, and then they, I don't know, whatever, they put in a dry pack or something stupid, and then they pull a vacuum on it, thinking that they're helping in some way. Just the shrinking of the plastic will put 100,000 volts on the inside surface. Well, it takes what, about 8 volts to kill a chip, 12, 15 volts to kill a chip that's a 3.3 chip, and you don't want to do it. You want to use 50%. You want to put a little dry nitrogen in there, and maybe a little 50% humidity. Don't put anything in there that's got that's going to suck up more water vapor out of the air, and just package with a little bubble of air around it.
Drew, I think you may have missed that I said Purdue University tested this guy's device, and I built a Van de Graaff generator when I was in high school. Jumped the 3-inch sparks. We've all had static experience. Are you saying that all of the thrusters are a bunch of stupid stuff? I heard a number of colorful words.
The thrusters, you mean like the little?
I don't know. I said something about an ion thruster, and you go on to say that's just hokum. What are you talking?
Oh no, ion thrusters are just shooting gas out your butt.
Well, then what are you saying? Are you saying that you cannot put a corona point in a ping pong ball and get thrust?
I don't know what a corona point is, dude.
Well, what I'm asking you is, what are you trying to do? Belittle what I shared that Purdue University did.
No, I just said that the guy was
using
sonics
that for the benefit of the group. Ion thrusters aren't just ion wind by Purdue University.
Ion thrusters aren't ion wind, but those little lifters are definitely ion wind.
Yeah, well, I appreciate that. And what I was only reacting to is because I thought I heard that remark. So I'm just
ion thrusters are
all
just
I'm doing is trying to defend the status quo here. Thanks, guys.
Okay. Ion thrusters are little more than just a clever chemical rocket. It's
There's
just
nothing about
electrically accelerated chemical
in
rocket.
them. But now, okay, let's then examine this just a little bit. I said, now let's assume this thought experiment. Purdue tested this and did find out that there is some sort of attraction, a torque put on a needle in a ping pong ball that shouldn't have anything to do with wind. So they tested it and it happens. So let's assume that happens. It's not wind. It's not inertial reactions of ion acceleration in electric field. What could be going on? You get a lot of curved voltage points at that needle, or we want to just rule out everything because
What are you saying?
knows
Somebody put a needle in a ping pong ball and then levitated it?
I tell you what I described, I would like to be heard. Listen, for the group here, the needle was in a ping pong ball. There was 2 of them. They were mounted on an arm. He had a patent pending at least on it. Purdue tested it for him. They got ion thrust inside of a ball on a little arm with 2 ping pong balls going around. I share that. And the guy was bought out and he disappeared. I posted his site. This is like,
do you know what you've just described? Asymmetrical electrostatic propulsion.
Exactly. I'm trying to point out that there's more going on than ion wind.
Yeah. Well, I
think
think you guys, you're missing the point, Don. Don, I'm the patent holder on electrostatic, asymmetrical electrostatic pressure. You just literally described one of my thrusters. So thank you. Yeah, they definitely work. You can definitely generate thrust inside of a ping pong ball with a needle in an electrostatic field. I know. I do it all the time. I don't do it with ping pong balls because
sorry, I
care
couldn't
about
even understand what you were trying to explain. I couldn't understand what you're explaining.
The short and long of it is the lifters, they're very entertaining. I built them for years. I really did. I thought that was the answer to the universe. Turns out it wasn't. They're very intense. They're fun. And the first time I actually had a vacuum chamber that could pull a decent vacuum, they were instantaneously discovered to be what they are, which is a function of air. You have air or some sort of polarizable gas. You can make lift with a lifter. It's an entertaining idea.
Curiosity of minds about that has brought us all together here. And Tim Ventura is the guy that
yeah, lifters were a blast. I spent 10 years building them.
You're the world expert on this. Anyway, I'm the newbie here. Thank you all very much. I was trying to defend Tim's legacy, and I was just all confused.
Oh no, no, don't. Yeah, you know, I got out of, well, one of the reasons I got out of lifters was the ion wind. Now I tend to think that there's more going on than just that, but yeah, I mean, from looking at it, when you get rid of the ion wind, whatever's left over from that design, it's not going to get you where you need to go, right? And so that was kind of why I got out of it and started looking at other stuff.
You rearrange some of the pieces of that puzzle, and you can make a fairly decent asymmetrical electrostatic pressure thruster.
Yeah, and now
what you guys rearrange some of the pieces of that puzzle.
What you guys are doing is more of like a flat pancake arrangement, right?
It is now.
Yeah,
but when we first started out, it was basically a grid, some kind of like a comb, and then a plate. So
see, but the reason and I
then we could just make all the thrust we wanted in either direction.
I experimented with those and personally never got any results. But Hector Serrano, and I'm sure you're familiar with Hector, right? He's been talking about, he's been talking about that forever. But then he's had his share of difficulties too. So
yes, I know. I worked with him for many years.
Drew, did you say that you put one in a vacuum chamber and it didn't work?
Put a lifter?
Yeah.
Yeah. They don't work in vacuum. They can't. They're set up to operate off of ion wind.
You just said, though, you believe that it's not all just ion wind.
No, I said if you rearrange the pieces of the puzzle into an asymmetrical electrostatic thruster, you'll make thrust. But if you put a stick of lifter in a vacuum chamber, it's going to sit there.
To find out what happens. My mind's not what it used to be, but I do recall Purdue tested it in a vacuum.
They did. It failed.
Oh, it didn't work in a vacuum?
No, it's never worked in a vacuum. It can't.
You know the one I'm talking about for sure. Or are you just saying this because you think most of them are? I'm trying to tell you the guy got bought out. Somebody dumb bought him out if that's the case. I'm just trying to share. I'm not trying to argue.
That's fine, man. If somebody got a lifter to work in a vacuum chamber, then more power to them. But
I have a video of NASA having one work in a vacuum chamber.
Okay. Well, anyway, I feel better and I appreciate it all. Thank you guys. Nice warm fuzzies.
That guy who does the Action Lab videos, he did one in the vacuum and it didn't work.
Because it can't. But again, if you rearrange the parts a little bit, you can make it work because it's a completely different creature at that point.
You can make plasma in a vacuum.
Oh, you're talking about like thermionic emission.
If you rearrange the pieces and it works, how is that not an anti-gravity design?
I didn't say it wasn't. I said it's not a lifter.
Okay,
Yeah, so you're talking about asymmetrical capacitance, right?
I'm just talking about yes, essentially, yeah. Yeah, that's what somebody coined it. Yeah.
Yeah, so asymmetrical capacitance, and that's more, what would you say? That's probably more aligned with T.T. Brown's vision.
Well, we're all looking for effects. Michael Faraday didn't get much effect out of that wire that deflected a compass needle, but he knew he's onto something, and that's what we're looking for is the effect, because you could give it to a team of engineers. 50 years later, the effect is driving cars at 90 miles an hour and stuff like that. So it's all the physics of it that our minds can hopefully get together, and some stuff can float to the surface. So that's sort of why I'm here, because there's so many missing pieces, and you guys are exciting on the mind. Appreciate it. Matter of fact, thank you all for entertaining me and allowing me to be here. I've been wanting to be here for a long time, and I don't know how to talk to people. Yeah,
well, Don, thank you for
I'm self-learned, and I'm an example of why I shouldn't self-learn. And my project came out overlapping 3 disciplines, and nobody understands me. So hey, I appreciate you all. Mixed discipline bunch. Thank you.
Don, thank you for coming. Thank everyone for coming. That's again, I mean, my hope is just, community building and everyone learns from each other, right? So that's, I mean, that's the ultimate goal. And then it moves all of this stuff forward. And I think this is, for some reason, this seems to be the time. So on that note, let me see, we're coming up on the top of the hour. It's almost 7 p.m. I had it scheduled to go for 4 hours until 8. I'm not sure. Does anybody else have anything? Because it looks like folks are starting.
I'd just like to ask the group, has anyone seen anything on the Evo CubeSat? Any results that have been released about whether their thruster works?
They haven't gone up yet. They postponed. They or as Drew said, they pulled out. But
y'all realize that's just a knockoff of our patent. It's literally a comb thruster that we designed and patented, I don't know, 4 years ago now. If you want to know exactly what they built, go look on their website, look at their silly little video. When you see the thing where it shows the window and you look at inside the window, go look at our patent and you'll see that design. It's nothing but a plate thruster. So I hope they succeed. It'll save me an expensive trip to orbit.
Well, there you go.
All right. Thank you.
Anyone here heard of reverse flyback voltage?
I'm sorry?
Anyone here familiar with reverse flyback voltage?
Reverse flyback voltage. In what context?
Flyback
it's otherwise known as surge power. Like, you buy a surge protector to protect against it.
What are you talking about? Electrostatic discharge?
And when you energize an inductor and you pulse it, right? You remove the charge in between pulses, you remove the charge. The inductor field collapses to 0 volts, at which point a reverse flyback voltage enters the inductor from the ether. And if you got 2 arms of a coil, left and right, left is negative, right is positive, the coil will invert and the left will become positive and the right will become negative, and so on. That's called reverse flyback voltage. So when you energize an inductor with DC 12 volts and you remove the positive and the inductor falls to 0 on volts, at that point you have a surge. which is called reverse flyback voltage. So they got a flyback coil installed on old TVs because they used to explode when you turn them off.
Yeah, I know what you're talking about. I've heard of that. Some people actually use that as extra voltage. It's like capacitance. It's like dielectrics. When you remove it's like electrostatic stays there, and then once you cut it off, it basically goes back to the source.
It's how they bring capacitors to high volts, because this reverse flyback voltage, you may give it the inductor 12 volts, but it's in the hundreds of volts with, very low, next to 0 amps though.
Yeah. The flyback circuit's opened up. The open circuit has to have a lot higher voltage. It's translated to a higher voltage when the circuit opens up to be the same power level. It translates power. The power stays the same. It translates the voltage when the collapse of the magnetic field happens. As scientists understand it, it doesn't come from the ether, although everything comes from the ether, but it's a collapse of the magnetic field falling again that is passing through the wires.
It's basically it's basically reverse AC. I mean, that's really the simple form.
Flyback transformer, like Ed mentioned, they're used in TVs. That's that big wire that goes to.
So it's like the 0 point crossing in the AC circuit. It's like
the circuit opens up to high impedance. So you have a low impedance magnetic field with a lot of current in it. You open up the circuit, you got the energies in the magnetic field. It instantly goes back. So you get a higher DVDT crossing all the coil windings because it collapses so fast on an open circuit. So on an open circuit, the equivalent power has to translate to a lot higher voltage to be the equivalent wattage that's in it.
Yeah.
The same thing as the spiral pulse capacitors they was testing with before they invented lasers, trying to make beam weapons out of Tesla stuff. Spiral pulse capacitor would translate to this gigantic 100,000 volt pulse when they opened it up, and everything collapsed real quick. So it's flyback inductive.
Yeah.
Kickback.
So that should be totally incorporated into any type of ion propulsion.
That's a good point. And also the that and the spiral pulse capacitor is quite amazing because it can be ran at resonance. And what it amounts to is a magnetic collapse going around the spiral pushes extremely high voltage under the open circuit with it. So for some really high amperage, super duper high amperage stuff, you could get a resonant spiral pulse capacitor. Those are patents from the 60s. You can even search it up under flux capacitor. It actually was called that before the movie. But of course, that was like your defense contractor stuff. So you got to dig into the patents for it. You don't find a lot of people talking about
Don, can you describe the spiral capacitor?
It's actually a double capacitor. You charge up, you take iron, or you take a iron or copper, doesn't have to be magnetic ferrous material. Take 2 layers of it, roll it up. Okay, conductor, dielectric, roll her all up, and you get and you tie the 2 conductors together on one end of the roll, but the other end you leave them open. You charge it all up to say 100,000 volts. Oh, no, not that much, 50,000 or such. What they were using it for is pulse compression, trying to get maximum energy for their ion beams they were going to use to do whatever war people do before they invented lasers. So when you short half of that charged double capacitor, the shorting wave going around that capacitor converts 95% of the stored magnetic flux to high voltage. So you could get a resonant spiral flux capacitor and call it a flux capacitor and get a lot of PR out of it, get grant money and everybody's happy. That was a punch. It was DQ, but I tried.
Comes in. That's where the iron core comes in. You get more flux from the iron.
Yeah,
I got to go.
It didn't have to be iron.
Been fun. Gotta go.
Hey, can I toss out a real quick question? There's a guy out there I read about years ago, Van Flanderen, Flandern, and he put out he died a few years ago. And he put out a thing called the speed of gravity, where he's talking about the speed of gravity is greater than 2 × 10⁻⁻⁶. Has anybody read that article? It's about 25 pages. And And he put a pretty convincing argument out there for the speed of gravity being really fast.
Yeah.
I'm not talking
I
about
read
gravity
that.
waves. I'm talking about the actual effect. So if
The
the sun
actual
were to
effect.
disappear, you know, it wouldn't take 8.5 minutes to figure out that the sun was missing. You'd figure it out instantaneously. So anyhow, has anybody read the Van Flanderen stuff?
Yeah, I read that years ago.
Yeah. What'd you think?
Well, let me see, because I interviewed him. He had a couple of interesting. So at the time, what was his other thing? He had another one. He had this crazy.
He had some crazy stuff at the end.
But he had this crazy idea that the Earth, that the moon was created by basically an object, a Mars-sized object slamming into Earth, and the moon was the remainder, the ejecta, which is now accepted, right? That's
Yeah,
the
he
accepted.
was the first one to pitch out the Thea impact idea.
And so there was that, but then in terms of speed of gravity, what he was saying was very simply, he's like, look at the orbital trajectories, right? He's like, if the speed of gravity was in fact the speed of light, the orbits wouldn't work. So, you know, but at the same time, if that was true, you'd think NASA would have figured it out by now. I mean, I've never tried to do calculations on that, but
I don't know, he's got about, yeah, like I said, it's about 15, 18 pages. And you can skip the math and just read the words, because I have to, because I don't do this math. But it's a pretty convincing argument.
So he was basically saying that he's basically saying gravity is faster than light. Is that what it was?
Yeah, he's saying that the speed of gravity, if not infinite, is pretty damn fast.
So there was another part of it too, and the other part of it was they in 2008, I think, when that comet, or no, what was it? They did a scientific test. It was light coming from a distant pulsar or something like that, and it went around Jupiter, and they used Jupiter's gravity to review this. And they said, I don't remember the exact details.
Oh yeah, the planet was in the wrong place for a few seconds. If gravity if gravity went the speed of light, then the planet should have been here, and the fact that it wasn't proved that was. Yeah.
This I think this was after Van Flanderen died, but I remember at the time there was criticism, and I was one of the ones who agreed with this. You're using the speed of light to measure the speed of gravity, and then it comes back as the speed of light. You know, so
anyhow,
that was my thought. Was
if you haven't read it, it's a great hour's reading. And it's called literally, if you just go out there and look it up, it's called The Speed of Gravity by that guy.
Yeah, Tom Van Flanderen. I can probably look it up.
And by the time you get done reading the last page, you're like, this guy could be onto something. So I don't know how that makes us go faster than the speed of light, because I wish one of y'all would figure it out for me. I mean, I got the impulse engine. I don't have the warp drive engine as much as I wish I had. So I truly hope one of y'all figure out the whole warp drive thing, because I want my spaceship to go faster than the speed of light personally.
There we go. I'll paste in. So there's Wikipedia. Wikipedia has an entry about him now. Or who put that in? Oh, yeah, Tom Van Flanderen. There we go. What else do you have? Face on Mars.
Yeah, he had some crazy stuff toward the end.
Well,
the universe
for a
is
period
decaying or something, or
I mean, for a period of time, this is just my bent, and I'm not gonna, but you have to be open to change, right? And for quite a while, there was a lot of uncertainty about Mars, and now it seems it's still possible, but it seems more certain that there's nothing going on there, at least to me, right? I'm not gonna, if anybody is a devout believer, I'm not gonna rain on your parade, and I like to say that I'm usually the first person to be wrong about anything, but it seemed it. Oh, sorry, go for it.
No, I would say probably not now. I feel like I feel like it was like a future. It was like a past Earth, and now it's just desert.
I think that's probably likely in the distant past.
Yeah.
I mean, I guess my heartfelt thought on it was with the face on Mars, when they first discovered the probe images, right, of Cydonia that came back, there was a giant thing about it, and some people latched onto that idea, and they didn't have validation either way for many years. And even after they had validation, it was kind of iffy. And for me, this is like one of my takeaways for this is, like I always tell people this, is don't marry your idea, right? Be open to change, because I mean, especially when I was doing interviews for American Anti-Gravity, I met a lot of folks who came up with an idea, and for whatever reason, it was basically disproven and they just couldn't let it go, you know? And sometimes you have to let it go. I mean, sometimes we're mistaken as human beings, you know? So.
I got something to say about.
Yeah, go for it.
Okay, you ever look at the TV? It's been on for days and nights, and the little dust layer on the TV, that static charge on the TV screen. So,
okay.
Well, that is what determines each planet's gravitational force, is that static charge. Not just like the ion propulsion thing, it's a static, and which is why it works for anti-gravity.
I completely agree with him, by the way.
That makes so much sense.
It's not speed. It's not speed. It's not moving at a rate of speed. It's a rate. It's moving at a rate. But that rate doesn't have to equate to a distance, because you can create a frequency with a frequency generator. It's not moving anywhere, and it's moving. It's pulsing at a rate. It's not moving at any speed.
Yeah.
As far.
So I guess the actual question about that. So based on the TV, are you saying what's pulling in the dust? Electrostatics or gravity?
The oscillating frequency of that static.
Well, it's electrostatics. I mean, there's a charge on the surface and there's a charge on the dust, and they're attracted to each other with Coulomb attraction. But that's, I want to push it a little further forward. The genius behind my propulsion system, he's out there thinking that there really is no such thing as dark energy and dark matter. He's thinking that everything, including gravity, is really a variation on a theme of electrostatic pressure. So
yeah, and in that case, gravity would be what they call shadow force.
Right. So there is no whatever it is, the fourth force of nature. Gravity's out there, and the first three are the atomics and electrodynamic or electromagnetism, and then there's gravity. No, gravity is another form of electrostatics.
Yeah,
it's just one that we don't fully totally understand, but the fact that I can make gravity happen with electrostatics leads me to think that maybe they are very much related.
Well, so the thing to look up there is Lesage theory. There was a fellow named
push gravity.
Push gravity.
I was going to say, based on that, I feel like gravity is a byproduct of electrostatics. I feel like you have to have that energy first. The density of the energy determines how strong that gravity is going to be.
I completely agree with you.
Yeah, and so so there were two things that one of them is obvious, right? Which is gravity is so much weaker than the other forces. And that's what led him to believe that it was a shadow force. The other one, which is, I've heard this a couple places, but basically what they were saying was the vast majority, when you look at particle interactions and stuff like that, it's push, 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 right? Particles hit each other, they exchange everything except gravity. Now, magnetism is so with gravity, the idea was it's still a push. It's the outside pushing in. It's the universe pushing things together because it's partially shielding. That was the idea.
Lesage was like 350 years ago, so he had this crazy nonsense words like corpuscles or something like that. Yeah. But it's basically electrostatic pressure. We have determined why gravity is so much less than say the Coulomb effect. That's because you're messing around with the permittivity of free space, which is like 10 to the minus 12, and you're messing around with I forget the buzzwords, the fineness ratio, I think it's called, 1/137. Well, if you go look at our math, it's 1/137 squared times the permittivity of free space. And it's right about that's about the same order of magnitude as the difference between electrostatic forces and gravity forces. So we're pretty much figured out which one's doing which.
Didn't Richard Feynman say that the nuclear bomb's energy comes from the electrostatic pressures?
Wait, gravity changes everywhere you go. Hold up. Gravity changes everywhere you go. We already determined that. So
the energy is everywhere.
So the real trick, guys, is taking all of this magic and wondrousness and stuff we understand, and somebody crack this warp drive thing before I die of old age. I want to go visit cool places. I want to go visit some of these planets that they're finding out there with the Kepler and the Hubble and whatnot.
That's not fair. You got Disney World down there, man. That's all you need.
I don't want to see a bunch of Mickey Mouse stuff.
Did you see what Grush said in an interview, or what came out just a few days ago? He said there was this, and this is harkening back to the time technology. He said there was a craft the guy walked into, got a little nauseous, came back out. It's 4 hours later, and he said inside it was stadium sized, but it was only a 30-foot diameter craft.
I read something about that. So, and if I'm correct, I might be mistaken. Grush had a interview in the Parisienne, right? Is that the one you're talking about?
Grush is this latest whistleblower that came out with a whistleblower library under the whistleblower laws Congress just passed to get follow through with the ATIP, whatever programs those were.
He had a couple of interviews though, and that's something to be aware of. They don't contradict each other. Yeah, there was Ross Coulthart. Ross interviewed him. That was the big one. But there was also, unless it was fake, and it could be fake, but there was supposed to be an interview in the Parisienne, which is a French newspaper. It's like one of their big newspapers.
Yeah, I haven't heard that.
Okay, yeah. So if you look that up, let me see. Somebody forwarded that to me. Grush UFO.
By the way, I had the AI. I talked him into a language model that included some of the physics we're talking about. And I said, so describe what a UFO will look like if it's in a time bubble buoyant in the gravity well. It described exactly what Bob Lazar said it looked like.
Okay. It's in La Parisienne. And I'm going to paste in the Reddit link that somebody sent me because the original is in French. So yeah, I would say take a look at that link. That's a second. Oh, I'm sorry. Go for it.
My bad. I was gonna say what baffled me about Bob Lazar's statement when he was working with the anti-gravity object with the whatever it was. He had basically said that the element or whatever it was producing its own gravity without radiation, and that kind of confused me when you have when basically electromagnetism is basically, or gravity is basically the byproduct of electromagnetism, which basically creates radiation. So it was kind of confusing when he said that, if you understand what I'm saying. Yeah. But he had basically said whatever he was working with created his own gravity without radiation, and I was like, well, it's kind of weird.
Well, volts is pressure. So if you look at a lake, it's got a certain amount of water in there, and that's the same amount of pressure as in volts. So you can put 2 leads on that lake and get that much volts because there's that much water in there. So, between the ground and the air, it's 2 different pressures as well. I mean, all you gotta do is change voltages, with no amps. You don't need amps to create volts. This is an illusion. You need potential to create volts, not amps.
Yeah, you don't need amps.
That's understandable.
Yeah, Well, I mean, amperage is how much there is, and then voltage is how bad it wants.
Yeah, I mean, volts can be anywhere. Amperage is basically whatever force is pulling whatever is out the voltage. I mean, basically.
There's way more volts than amps.
Volts don't do anything. They really don't. It's the field that they create, and the field comes from charge. You can make a wicked field from charge and have low voltage, as long as you have enough charge built up.
But moreover, it's the rate of change of the field.
It's the AC, it's basically the frequency. I mean, the voltage can be 3 volts, and I mean, you can oscillate that very, very fast, and it can create a field 10 times the size than what you're putting into it.
It's going to create an electromagnetic field for oscillating it.
Yeah, it's going to create an electromagnetic field, but it's going to create an electromagnetic field 10 times, but depending on the frequency that you're putting in, it's going to create something way larger than what you're actually putting into it.
Harmonic amplification.
Maybe.
Harmonics, yeah.
Well, getting back to the lake, if that lake is level and it's not draining, it has no amps, it just has volts. As soon as you tilt that lake, the degree of tilt determines the amount of amps behind the same amount of volts in that lake. The volts don't change. Only thing that changes is the degree, the angle of degree in relation to what? Gravity.
Yeah, and in that case, though, the water molecules would be actual charge. Little positives or little negative, little packets of charge. When you tip the lake enough and all the charge runs out, that's the lightning bolt. And eventually the charge runs out and you run out of water, and then you got nothing left.
Yeah, the voltage will definitely change. So are you saying regardless of how many amps are being pulled, the voltage will never change?
I think the wattage is the term, the power.
I'm saying the energy was conserved. Even if it was not turned into another lake, the volts in those water molecules, whatever, went somewhere else. It didn't disappear. They went into
but
the
they're
air.
running. Yeah, but they ain't that lake no more.
Yeah,
that's
what I'm saying. Like,
you drain the lake, there ain't nothing in the lake no more.
Energy can't be.
The volts are definitely gonna. Yeah.
Yeah, that water may be downstream somewhere, but it's not that lake no more.
Yeah, if you're pulling a lot of amperage, the volts are definitely going to go down. They're not going to stay the same.
So the voltage, when the voltage leaves the water on the land and goes into the air, you have voltage in the air. What do you got? You got storms and stuff.
Yeah, you really want to be using the word charge and not voltage. It's where that charge is going.
Yeah, the charge is just the number of volts. That's what the charge dictates.
Charge is the thing you're calling voltage is really just a measure of charge.
Total energy. Total energy.
It's basically that saying energy can't be destroyed. It can only be transformed.
Yeah.
That's basically what it is.
Sure. Is anyone know more details on time? Excuse me, I am sort of
I did have.
Oh, sorry.
No, I just had something. I had something I wanted to add to that. I had something I wanted to add to that because I know we were talking about time travel in the comments, and we were talking about and you guys were talking about interstellar travel, and I was in agreed of my understanding with like what I've been doing my research. They're pretty much the same thing, and what it kind of involves is basically frequencies, different. Basically, like we look at time as linear, and time isn't outside of this planet. Time isn't linear. It's basically is there. Like, so basically from my house. Basically, from my house to down the store is basically the same from, past and future, basically. You can get there using the same methods, and it's going to take the same amount of time to get there. It's basically not going to take like we think of time travel as like we think of distance when we think of interstellar travel, but it's the same thing as if we were talking about time travel. You can get there in the same amount of time as if you were going down the street, basically from past to future.
Well, to throw in some anecdotal stuff, it's more than likely fake, but there was this talking alien video that the military was supposedly debriefing. And the alien says he traveled for 100,000 years to get to this point in time through space. And they ask him what he's talking about. He says, space is time. So there you have it.
Yeah, I've seen that one. I think that one is fake though.
Yeah, very, very entertaining.
Well, in theory, to move faster through the same, what we call distance in space, we need to create more oscillations per second to get there in a shorter period of time, just like a wheel spinning on a car needs to spin faster to get there in a shorter period of time. It doesn't mean you have to spin a wheel on a car to move through space or time. It just means you need to create more cycles per second because in theory, when you're spinning one wheel on a car 360 degrees, you're doing one cycle per second in the real physical world with that machine or your two legs. Because that's the cycle of when you make a step or two steps or whatever it is. One step could be 180 degrees, the other step is because it's solid geometry. You can't do a cycle of any kind except on the physical world. If you're in the non-physical world, then you don't need to do any cycle.
Well, that's an interesting concept about cycles, and I use the word a lot, harmonics. And if you want to consider that what an atom is, it's definitely self-harmonic. And it seems like we want to make in, if we want to couple into the phase space per se, or move at the same time it does, just like two satellites in orbit, you can hold hands, tie them together. They're still, I mean, if they're side by side in orbit, you match phase space in and out at the same place. Those quantum fields, whether they're electrical or any other field in the fabric of now, in that same phase space become one coherent entity. When we can get coherent on the fabric of space-time, I think we're starting to get closer to what UFOs are doing. But then what do we do? Obviously, they have a lot of energy punched into that because you know, they're bending light around it, et cetera, et cetera, et cetera. Now, maybe there's a harmonic buildup to where they don't have to have that much energy. It can accumulate. Maybe those things have to sit on the ground and ramp up for 5 hours. Who knows? But anyway, it is about harmonics, getting harmonic with something until it doesn't act the way it used to. And again, to wear out my hat, and I think that something is the nuclear field. We've been around the block so many times with electrons.
Yeah, I mean, I would say what you're actually saying is correct. It does have a lot to do with harmonics. It's basically frequency. Like it's just like if you put two frequency ports beside each other and you tap one, the one beside is going to start resonating at the same frequency. That's basically the same thing as time travel. If you are able to generate the same frequency as a certain point in time, then you will match that frequency and you will become that frequency. So you would basically be bending the space and time around you, and you will actually just become that location. So it's no form of propulsion. It's just going to that. This is going there, basically.
That's in par with the vibrational theory. You know, Tesla said, think in terms of vibration. Now
it is. Vibration, frequency. It's all the same. I mean, it's the same. It's basically the same word.
Space. Don't think that vibration has to move anywhere to get from point A to point B in space. What if it just formed in space as is, in place, as a vibration, just like the standing wave?
That's what quantum mechanics entails. That basically everything is already connected.
I mean, what if it's a, you know, ever heard of Birkeland currents? You know, those are like what we used to think were stars. We figured out later that those were huge lightning bolts the size of universes. And this is not a joke. A lightning bolt the size of multiple universes. That's what a Birkeland current is. Now, What, I lost my track there, but.
And electric universe theory is what it sounds like. Electric universe theory says that the cosmos is organized by electric fields, electric streamers between mega clusters of galaxies, etc.
It's very much on the end of things being electrical in all ways, shapes, and forms. Everything is electrical. Like there's this channel called the Electric Universe. They make good little short documentaries on that. You know, like the Grand Canyon and all the black scars on the rocks. I mean, I'm an electrician for decades. I've seen these black scars all over breaker panels. It's exactly what it is. It's high voltage contact to grounding. You know.
Have you heard of W.B. Smith?
If you're an electrician, you know what kind of lightning bolt that requires. That's not your average lightning bolt that hits a lightning bolt that makes those huge black scars on the sides of canyon walls. You're talking about lightning bolts that we have never seen, probably as humans on this earth, you know. So, and then getting back to the Birkeland currents, you know, being lightning bolts the size of universes that are way out there, that are so small that they look like stars to us.
I'm gonna have to research that. I haven't heard of that yet.
Electric universe. It's electric universe theory.
Birkeland, the guy's name is Birkeland. He's an astronomer.
Birkeland was a Swiss guy that realized that ions traveling through vacuum form dual helical with a barrier between them. They just organize themselves like that. And then the electric universe people picked up on that and let everybody come in and add any kind of theory anybody ever wanted to talk about. And it's this big stone soup of everybody's theory mixed together that it's not organized by gravity, the cosmos. They say it is organized by electricity, like you're saying. Electric universe. They'll take your dues.
Well, I mean, basically, I believe Birkeland theorized that what we thought were stars were big lightning bolts before he died and before it was proven. Later, the telescopes became advanced enough to actually prove that.
So, what do you mean by what do you mean by lightning bolts? Like, what are they doing?
They're not doing anything. They're moving at a rate of what we call speed, and we all calculate speed and we translate it into something as a distance through space, which it should be nothing more than a rate, and not, you know, what we should not look at the word speed as moving through a mile or a kilometer. It's a rate of oscillation is what speed should be seen as. So that's what the lightning bolt is. What I'm getting at is this lightning bolt is so big that I can't tell you the rate of speed it's moving at. It's probably not something within our realm of measurability. It's something that all we can see is that it's not a star. You know, and I'm not sure if they finished proving Birkeland's theory yet, but they began to notice some of his predictions, you know, to be looking to be the case to some degree through their, you know, analysis of the imagery and stuff. That there's a lot of evidence to suggest that these are not stars creating this light, and they even, I believe, they even got good shots of the bolt of lightning. I mean, it's like not a bolt of lightning per se, but it looks like an energy band.
Thanks,
that they thought were galaxies before or something like that.
That's interesting.
Does anyone have connections to some of these old guys? I'm fond of William W.B. Smith. He was the Canadian guy that detected a UFO. Anyone? And he was tied in with time travel. Not travel, time, bending time. Okay, no one had heard of him, huh? Well, he was out there. Anybody want to know? The CIA was all a buzz when the UFOs were over Washington back in what year? The 50s? There was formations of UFOs over Washington.
Yeah.
Right. Well, yeah. At that time, Wilbert B. Smith went back to Canada. He was taking care of the ionospheric research to get the legislation worked out for AM wave propagation and how far radio stations overlap. So he says, you know, they're talking about UFOs in Washington. I think I can detect one with our ionospheric weather station. So he got an extra $1,000 budget and made a UFO detector station. And if it detected UFO, it would ring a bell and the weather station people would come out and look up in the sky, right? And the day it did, it was cloudy. And then they shut him down 2 days later. It probably went black. But he claimed to be in communication with them, and he also developed a means to meditate and talk. And so he goes way out there. But after my friend disclosed some information to me that was way deep in his military research, I got back to Smith a few years later and read that again, and a section of it really opened up. And what he was doing was taking a hollow ferrite tube, wound it with number 14 gauge solid copper wire and a caduceus winding. He put RF energy onto it, I would assume from an AM transmitter that he had around. FM wasn't invented yet. And he tuned it and worked it, and it would get warm until it came into interesting resonance, and then it wouldn't get warm anymore. And when that happened, and he could connect it to another antenna, and it would couple, and it didn't have to stay on the beam of the caduceus winding. It would stay coupled. So it was this weird nonlinear field that established at a certain magnetic velocity, rippling through the length of that cylinder. It was a ferrite cylinder.
You say after a while it didn't get warm?
Right. After it reached threshold and went into some sort of resonance, the energy didn't go into heat, but it went into establishing this emergent field, this nonlinear emergent field. And I don't know how he determined it. Didn't get into that much detail because he's mostly speaking to lay people. So you have to really read between the lines of the stuff recorded. His information was stored at Ottawa University by a guy named Arthur Bray and his fond, as they call it in French country there. So there was a collection of all his stuff that the CIA didn't scrub. He was in a meeting with the CIA, and interestingly, they bring psychics. An admiral from America came with a psychic to a meeting about flying saucers. And the CIA guy said, now, how are we going to take your word, Madam Psychic, that you are in touch with these UFOs? And they noticed a UFO right then, sailed right past the window on parade. So Wilbert Smith was in time technology, and it was almost totally scrubbed. Had it not been for Arthur Bray, I don't think there'd be anything about it. Then Dr. David Lewis Anderson, have you heard of him? He called Art Bell, the late Art Bell, back from the Philippines. Said he's working on time technology, and he says India and China are leading in that. Just picking all your minds. If you hear of anything, drop me an email.
Yeah, I mean, it's an oscillator. You know, if you're going to successfully build a time machine, in practical theory, if it were to succeed, it would be an oscillator of some type.
Well, I do believe I'll be checking out.
There's a good book on time travel by a PhD psychologist who trained in Tai Chi, and it's called Transcendent Dreaming, about her precognitive dreams as time travel. And I'm just saying, that's how I finished my master's degree, was training with a Chinese yoga master who levitated up 9 feet when he finished a 28-day cave meditation at Mount Qingchen.
That's fascinating.
Yeah, he meditated nonstop for 28 days in full lotus yoga position. And the whole thing about asymmetry is that all of Western science is based on commutative geometry as symmetry, and defining time as the seconds assume that time is a symmetric cycle. And so when you change frequency to angular frequency, you're assuming it's a symmetric cycle. So when you maintain the linear frequency, you can develop a asymmetric time shift as the cycle. And that's essentially the same secret that that the other fellow in Florida, Drew, patented, for the asymmetric capacitor or of electrostatic But if you just take that from photons, because even Roger Penrose says that mass is equivalent with frequency at the end of the universe, when all the black hole singularities, they go into pure photons. And at that level, all you have is form, and you no longer have size. There's no size at all. And he calls it fundamental time. And so in standard physics, times is considered to not be, like, every time you make an external measurement, it takes time to make it. And so this is what they call non-commutative quantum algebra. And it turns out it's actually Clifford algebra from the 1800s. And so I've been corresponding with Professor Basil J. Hiley, and he was the collaborator with David Bohm. And essentially he's saying that on the sub-quantum level, it's all this asymmetric time frequency. And so you no longer define distance with a geometric length. You define it purely as a time frequency resonance that's non-local. So you can have the future and the past overlapping, because the negative frequency is no longer canceled out. Because in standard symmetric mathematics, you get the energy from the amplitude. And so when you square it, you're losing the negative frequency. But if you're relying on a non-commutative phase, then you can have a negative frequency in a time reverse signal. And this is also what Louis de Broglie first discovered. He called it his law of phase harmony. And it's more commonly known as the de Broglie-Einstein relation. And I mentioned it in the chat earlier, but Paul S. Wesson, he had discovered that in his final research also, and said this is basically the fifth dimension, that, whether people want, it's technically not an ether, because it's active information, and it's guiding, all of matter is actually light, made of light, but it's guiding the light from the future as what would be called the gravitational mass of light. But it's actually this time reverse signal that's non-local. So whenever you make an external measurement, you're taking time to make it. But through meditation, it's been proven that we can listen to music up to 10 times faster than Fourier uncertainty, because in standard physics, you define time as a linear operator with frequency, and that's the source of the Heisenberg uncertainty principle. It's from the time frequency uncertainty principle. But if you realize that time is inherently asymmetric, when you rely on listening in meditation, you're using time as your direct medium. And so also it's been proven now in the quantum biology research, Roger Penrose and Stuart Hameroff, that are the microtubules and the tubulin in the brain are metamaterials. And so you get super radiance as a superluminal phonon energy. It's not technically energy, it's a new type of force, because it's before you square the amplitude as any probability. In fact, you don't have to use probability at all. And in fact, this is the source of what we call randomness, because
pure ether.
Yeah, it's technically, it's not an ether, because it's pure information, it's active information.
So
in the quantum whiteness.
Right. Yeah. So in other words, they're doing an experiment now on this with weak measurements, where they were using entangled photons before, but now they're going to use entangled argon. This is Basil J. Hiley's research. And essentially, when you have a weak measurement, you can prove that they even call it gravitationally repulsive. It's a newly discovered gravitationally repulsive force. But it's technically not energy, because it's before you actually square the amplitude to get the particle to exist. It's
at a closer radius to the nucleus. It
goes
up and then back down as you go away.
It's before the nucleus even exists. We're talking about a pure realm of time and frequency before there's space-time. He highly calls it pre-space. It's pre-space.
That's crazy. So it's after ether, but before matter.
It's right. I wouldn't even say it's after anything. In fact, it's before. It's what you were talking about, Therese, with linear time. It's before linear time. So it's the future and the past are overlapping. If you check out Basil J. Hiley, he says he has a recent talk on the emergence of classical physics, and he talks about how Richard Feynman was wrong. Also, with the latest Nobel Prize in physics, there's a guy, Professor Jean Brimon, and he says even Stephen Hawking did not properly understand the EPR Bell, inequality experiments with, testing the Einstein-Podolsky-Rosen challenge to quantum physics. In other words, it's the Bell inequality experiments that just got the Nobel Prize. They proved that there is instantaneous action at a distance. That's what non-locality is. And I mean, technically it's not action because it's information. So and this is the other fellow, Danny Cohn, you were saying this, it's about entropy, right? Well, this is what Roger Penrose says, this is negative entropy, it's negentropy. And this was known in the 1930s. I mean, Erwin Schrödinger's book, What is Life, was about the origin of life is negentropy or negative entropy, but in fact, the true power of the sun is not fusion energy. The true power of the sun, as Roger Penrose points out, is this negentropy from what he calls gravitational potential. So he said, and it's from frequency, it's from negative frequency, and so the gravitational potential, he says that most people call it dark energy, and they don't know what it is, but actually it's just this negative frequency that's at this it's a non-local resonance of the future and the past overlapping. So you have a time reverse signal as negative frequency, and all you have to, it's all because people have used the wrong mathematics that they develop the wrong physics, and it also explains basically all of our technology has been trying to decrease the entropy of matter. But as Roger Penrose explains, that gravitational entropy is the opposite of the entropy of matter. So all of our attempts to decrease the entropy of matter are actually increasing gravitational entropy, which goes against life on Earth. And that explains our whole, ecological crisis. Or if you just study geophysics, you can get into all that so it explains every kind of an anomaly in science, And Roger Penrose, nobody listens to him because he's 91 years old, and
I listen to Roger Penrose.
Oh, great.
So you're talking about the information space, and Roger Penrose is saying brain cannot calculate mind, has to be somewhere else. So mind is therefore a transceiver. And you're talking about the tubular things, which by the way are arranged in Fibonacci spirals. Isn't that cool? In the nanotubes of every cell body, numbered by the billions, right? The nanotube cell. So that those nanotubes, like you were saying, they determine when each neuron fires to make the mind wave as the cosmic something in the information space strokes our gray matter.
Yeah,
and the quantum inside, the quantum whiteness is where our source mind comes from, per the Orr theory of Penrose and Hammerhoff.
Yeah, basically this consciousness. I guess there's a bunch of different words for it, but I guess
right. Yeah, it's in quantum physics they call it proto-consciousness, because it's not the same as thinking consciousness. It's literally like if you look at Yakir Aronoff, he's been doing these weak measurement experiments, and he became famous for what's called the Aronoff-Bohm effect. And he says that the double slit experiment, the electron, it knows if the other slit has been closed or not. It has a non-local field that gives it that information from the future. And that's what those weak measurements prove. And they call that a gravitationally repulsive force. It's a newly discovered force.
Fascinating. How long ago?
That's interesting.
Side the light goes. The double slit experiment proved that you need a viewer to make it go either direction. There's a different person's.
Okay. Yeah, technically. Yeah. Right. Yeah. What they're saying is that, you have to do the experiment in the future to show how it's affecting the past. And so in that sense, the viewer is necessary, but they're saying that this pure time operates whether a person is aware of it or not. In fact, it's the origin of what we consider to be randomness. Randomness is just external measurements. And so without external measurements, we have this future and the past overlapping as non-locality. In other words, it's instantaneous in the fifth dimension. if we don't make an external measurement, we can access it through meditation, and that's what before Western science, that's what the ancient non-Western cultures did using. It's in fact the Fields Medal math professor. It's harder to get than the Nobel Prize Fields Medal math professor Alan Khan. He has a talk called Music of Shapes, and it's based on this physics studies called Can You Hear the Shape of a Drum? And it turns out you cannot hear the shape of a drum because it can have different geometric shapes, but even though the frequency is the same, and this is due to what's called non-commutativity. And so what that means is that Alan Khan says that music theory actually is the simplest model to explain this truth of reality, and he just calls it 2-3 infinity. And if you just study the basics of music theory, somebody mentioned like harmonics earlier, but the concept of harmonics already assumes a geometric spatial definition of time. And so when you just realize, if you really study music theory on a simple level, there's already the non-commutativity is like, if you take it as an undertone, the very first overtones and undertones are non-commutative. So the perfect fifth is the ratio 2/3. As an undertone, that's C to F. In music, as an overtone, it's C to G. And you cannot have those both existing in the same scale, because that's what non-commutativity is. But empirically, they both exist, and then that creates an infinite non-local overlap, of the future and past. So you can just think of like a string as 0 to 1, but if it's 3/2, it's longer than the string. What happens is you're constantly changing the root tonic. The fundamental tone doesn't exist on a material level, and instead it's just this infinite guidance of information as time and frequency.
Are you saying, Drew, that the future and the past are dissonant in the now?
Okay, I've personally experienced precognition from my meditation training, and I can assure you that if you have a precognitive vision, it's more real than being awake. In other words, if you study quantum biology, there's the Royal Society of London, they gave their Science Book of the Year award to a quantum biology book in 2016. It's called Life on the Edge, and it argues that like our senses originate from non-locality. So like our sense of smell is actually due to non-commutativity, and normally that's called quantum entanglement, but the whole point of non-locality, it's not an artificial construct. It exists inherently as the source of reality. And so what that means is that if you meditate on a serious level, like I fasted for a week on just taking a half a glass of water the whole time, like not every day, but just over 8 days, just a half glass of water. And what happens is that you discover that all of your perceptions originate from this non-local coherent source, because it's before time frequency uncertainty, it's before position momentum uncertainty, so it's actually more coherent. So when you have a precognitive vision, it's actually more real than being awake, and you will learn that from experience.
You reminded me of one I had.
Okay.
It took 40 years to close it.
Okay. Yeah. I had one come true 3 years later. I wrote it down at 2:30 a.m. in the morning, and I was keeping a journal at the time. I said, this is more real than being awake. I think it's going to come true. I totally forgot about it. And then 3 years later, all of a sudden I got this uncanny sensation, and it was a photograph. I won't go into the specifics, but it was a very, very, detailed, specific kind of situation. There was no way it could be, sort of like a chance thing or whatever. And so then I had totally forgotten about the dream, and I drove back to where I had my journal stored, and I looked it up, and it was exactly the same photograph. I had described it like, and what it turns out it's based on emotions, because the electrical, I have a training manual in my first upload on my YouTube channel, but essentially like the stronger emotions you have, you can think of it like developing a photograph. It makes a stronger imprint as electrochemical energy. And like in the traditional Taoist training, they literally say that each emotion is an organ of the body. And once you open up the pineal gland, that is actually like an electrogravitic transducer to, this formless awareness. And what happens is that you then experience reality holographically. And so what you discover that your external reality is actually a reflection of this non-local time frequency that's going on all the time. So if somebody around you has like an anger blockage, your liver will get really hot because the organ, the liver, like if somebody has too much alcohol, that's a liver blockage, and they get angry, right? But it's literally like your own liver will get super hot until you clear out that holographic, non-local energy exchange, and you do it through the heart, the right side. See, the other thing about the asymmetry is like ever since Plato, we were taught that the body is symmetric. That was his argument for. He argued that the number 2 existed as a Platonic form before counting as time. But that's really the square root of 2. The square root of 2 actually originates from the wrong music theory. So people are being brainwashed by the wrong mathematics ever since they're like 14 years old, because it's all based on commutative geometry.
Fascinating stuff. I'll buy you a beer to keep talking like that sometime. I mean, seriously, I'd love to hear you now. Is this a big academic career that we hear blessing us with all this erudite knowledge?
If you can sit in full lotus, you don't need to do anything else.
Yeah, I hear you. Well, let me tell you my story. I emailed you this, Tim, and asked for you to keep it confidential, but this guy's too much. I got to share a little more. I think you'll like it. I had a vision when I was meditating at 19 years old, trying to contact aliens, right? Because I was on a mountaintop in Arkansas with another weird guy, and we was trying to break through to spiritual realms unknown by man. And this guy got a message in LA that he better go out in California and get his brother and one other guy. And suddenly I was told, go back home and grow up, right? So I was at home trying to grow up, and I was meditating, trying to contact these aliens this guy talked to, and I saw this vision. And then 40 years later, a friend of mine for 10 years told me how to build a 30,000 watt version of the device I had built in that vision. It sort of messed me up.
Yeah, if you meditate more and more, you definitely experience synchronicities, what I would call, glitches in the matrix. And it's all based on a suppositional.
Yeah. Once you, it's like it's refound. It's like what do you call it? Refound knowledge. You basically, once you train your brain to redo it, it'll re-remember what it was, what is already known, but you don't know until you actually do it.
The recollection, it's the hard part.
Yeah, there's another way to think of it is, any kind of problem you have, the answers are out there.
Reverse amnesia.
Well, yeah, and if you want, I did a series of interviews on this. It's on my Tim Ventura interviews channel, and I can give you kind of I don't have ultimate answers, and I'm not going against anything you're saying, but so kind of the rundown for me was, again, starting last year, some of this came out of APEC, some of it was my own interest and stuff. I started doing a series of interviews on UAP. And I started with the really concrete stuff, right? Like Kevin Day and Gary Voorhees and folks like that. And it was like, okay, what did you see? Why did you see it? And then I kind of progressed on to people like Gary Nolan and folks like that, who are a little bit more hypothetical. It's like why is this happening rather than what happened? And one of the things that I found over this series of, dozens of interviews was pretty much without a doubt, every single one of these folks came back to consciousness at some point in one way or another. And even like in Gary Nolan's case, he was one of the people who kind of got me with it, because he even said at one point, I think he was talking about Skinwalker Ranch, and he said it comes back to this. And he's like, what does that have to do with UFOs? I don't know. And when he said that, I was like, God, how many times have I heard this? So I started doing a series on consciousness, and it gets on my YouTube channel. And there are a few different approaches to it, but the Global Consciousness Project, I'm a giant fan of their work. They're collecting data on it. So if you guys haven't looked at that, the Global Consciousness Project,
it changed to they took it out of the university.
Yeah, they did. They have another. Well, it was Pears in the university, I think. It was the Pears lab, and then it was GCP.
The Pears, yes, Princeton Engineering Anomaly Research.
Yeah, and so now it's GCP. It's just GCP, and I forgot the name. They do have some other organizations they're associated with.
Yeah, but it left in good standing. They said, we just don't have a whole lot more to show. It's a very small but significant deviation that mine does.
The
Well,
part,
what I
the
would-
part that
what I
got
would
me
rec-
though was, let me finish for a second, because I'm going to throw a monkey wrench in, and this may be good or bad or provoke some thought. I don't know, but you know, the idea that I was kind of operating on was that this psychic powers are entanglement, right? And there's actually really good evidence to suggest that they have a lot of the same features and stuff. And I got to global consciousness, and the problem there is, if it is entangled, then everything is entangled because it's not directed, right? Like basically what they would do is they would measure the impact of news events on these random number generators. The random number generators aren't connected to people, and the news events aren't directly connected to people. So that's why they were saying it's the mind or the consciousness of the earth. So what's interesting there though was I met another fella, and Bernie Beitman, and he has again, this is consciousness. He was saying that instead of being entangled with each other, that we're all basically entangled with, he didn't call it that, but it's basically the Akashic records. And he said, so when you think of a psychic event happening, he's like, psychic isn't necessarily from one person to another. It's from one person's part of these Akashic records to another, right? And so he was saying that this cloud, you could call it like a psychic cloud, right? Or I think he called it the psychic atmosphere. He said that we're all connected to that, and that connects us to each other. And that's how these weird indirect things can happen. So that's where I've made it so far. And I don't have anything more than that, but my hope was, you know, by telling you guys, maybe it'll plant a seed. So.
Yeah. And I'm not sure if you guys even ever heard of this, but I've actually I did something like that a few months ago with I'm not sure if any of you guys ever heard of Dolores Cannon, but she invented the QHHT technique. It's quantum healing hypnosis technique, where you basically go in. It's basically it's a guided meditation where she but what it mainly focuses on is past life regression. And I actually did one a few months ago, where I had sat down with the lady she was a practitioner in it. She was trained in it. I did the guided meditation with her, and I seen some things as I laid there while she was guiding me through the meditation that I've never even seen before ever in my life. You know, never been taught it in school or anything like that. And it was kind of weird because after I got out of the meditation, I went home. I was like, this is some weird stuff. I had to research it. And after I researched it, everything that I seen in my visions during the meditation was actually real. It had a lot to do with the Inca time period, with their civilization being overthrown by the Spanish conquistadors and stuff like that, and how they were overthrown and how they had to rebuild their civilization. But before that time, I've never researched the Incas or anything dealing with the South American Amazonians ever in my life. But after I got home, I researched what I seen, and everything was foretold that this happened in history. And I was like, wow, that's kind of crazy.
I'll reply to the comment. Annie Cohn asked me about the math, about the imaginary number. I've corresponded with math professor Luke Hoffman, and he collaborated with Eddie Oceans. What happened is that I studied, like I said, with the Chinese spiritual healer, and then as I studied the alchemy as meditation, I realized it was due to non-commutativity. And then I realized, well, somebody else must have discovered this. And that's how I kept searching on the internet, and I discovered this guy, Eddie Oceans, and he was working at the Stanford Linear Accelerator Center, and they hired him he created something called quantum psychology, but it's all based on non-commutativity. And he also taught Wing Chun, which is, Bruce Lee's lineage. He taught that at Stanford, and his argument was that the whole secret of the non-Western like internal martial arts and meditation, it's all due to non-commutativity. And a good example of that is what I learned my first year when I took quantum physics from Herbert J. Bernstein, who designed the NASA quantum teleportation system. And he taught us non-locality as what he called the Drock dance. And you might have heard of the Drock dance, but essentially, like if you're holding a cup in your hand and you have to keep the cup without spilling it. And so you have to turn your hand like that, and then you go around again. Now what that is that's the 720 degrees that's necessary in order to observe an electron, but an electron actually has 1/2 spin inherently, and that's the difference between non-locality and quantum entanglement. And what my quantum physics professor did was he tested the Bell's inequality with neutrons, and since neutrons don't have the magnetic field, then he was able to prove that the non-locality was inherent to the 1/2 spin. And so in terms of the imaginary number math, as I said, I corresponded with Luke Hoffman, who had collaborated with Eddie Oceans, and Eddie Oceans passed on early. So, but Luke Hoffman, he has papers on how the imaginary number is not due to quaternions, but instead, if you think of it as an inherent asymmetric time shift in the algebra. So what you can do is just say that I, the imaginary number I equals I over -1. And once you set up that algebraic equation, it creates a time iterant that's inherently an asymmetric time shift. And you'll have to read his papers for more details. But what that means essentially is that instead of defining the imaginary number as a square root of -1, what you have instead is it's +1 or -1, and it always is an asymmetric time shift as an eternal process, and that's what he calls primitive time, or no, he calls it primordial time. So his focus is on non-commutativity, but as I mentioned, Alon Khan, he just calls it 2-3 infinity, and he's considered he got the Fields Medal, for non-commutative geometry, and he says this is the true source of entropy, is that before there's any external measurement that's observed, you have the future essentially guiding the past through the discrete non-local factorization of frequency and time. And so by calling it 2-3 infinity, he's directly relying on music theory. So in music theory, he just points out that instead of the normal Pythagorean comma that people learn, what you have is when you have the perfect fifth, it's 3 to the 12th. So you have 12 perfect fifths to make up the 12-note music scale that everybody learns. And then you line that up with 7 octaves, and then people assume it's a commutative geometry, so they can transfer the ratio over, so it's 3/2. You just add the 2, so you get 2 to the 19th. So you get 3 to the 12th approximates 2 to the 19th. But what people don't realize is when you reverse the time to put that back into the same scale as a symmetric octave, then you have a non-commutative exponential. So then it becomes 2 to the 1/12th, or 3 to the 1/19th, because that's what makes them non-commutative. And his point is that this is a very simple intuitive notion, but it proves that the non-commutative discrete ratios are more dense than the real number space-time continuum. And so because they're more dense, you have this future and the past overlapping so there's no geometric length anymore. And he points out, like even our standard for time now is based on frequency. The cesium time clock is based on quantum frequency. It's not based on, and that quantum frequency is inherently non-commutative and non-local.
Yeah. Well, guys, we're actually past the top of the hour. We should probably wrap things up for this session. It's been absolutely wonderful having everybody on. I think that I would call this a giant success. So just to let you all know, basically what we're doing is we're alternating. We're doing the APEC presentations. We're going to do those once a month. And I actually have a schedule for those that I'm going to put up on the website. We're updating that. And then the open mic sessions, we're going to do those. Those are also once a month, but they're staggered by 2 weeks. And that gives us kind of a breathing room. One of the challenges that we had in the past was we tried to do both. And what we found was, especially in terms of people presenting new ideas, they didn't have enough time to kind of get their stuff together. And then in terms of PowerPoint presentations, we just overran what we were able to do. So staggering them kind of helps. It gives everybody a little breathing room. So, but yeah, again, it has been absolutely wonderful having you all here. Thank you so much. So if it's okay, why don't we, we'll call this a success. Here, you know what? Let me put this on gallery view. Everybody who is still with us, if you're open to it, let's do a big hand for open mic number 1 for APEC. Thank you, everybody, and have a wonderful, wonderful weekend.
All righty. Everybody have a good day.
Thanks so much.